Greetings of the day to students and welcome back to ptscadexpert and myself architect Kumar Kapadia from the city of Surat in Gujarat. And for this course, Master Diploma in Revit BIM, which is the combo of architecture plus structure plus MP, what all we have seen so far is all this 3D drafting commands under this architecture tab, under this build panel and this circulation panel. Okay, but as we've been always saying that Revit is not only about the modeling of the 3D interface, but it very prominently and efficiently does models the 2D interface, that is the essential building information and the data which we feed to a particular structure for its execution on site. That is the dimension, detail, text, that is the nomenclature, tagging part, colorful legends, and symbols. But the implementation of all that, I'm going to show you onto one complete project which we are going to execute from scratch today in Revit. So the live project this time for your batch, that is August batch, is going to be once again the real life executed project which I have found from online portal, and it is a very interesting project. The Khayal. The project name is Khayal by 7th U Architecture Studio, and these are some facts about the project. And its location Kerala, India, and area is 2920 square feet. And it is a very interesting project which we are going to execute today. And they have provided with this floor plans and this two sections. Okay, and the most important part, the unique part of this particular project, the most essential highlights of this project is this particular sloping roof. And it has, you see that this is the ridge and it has an unequal pitch on both the sides. And you see that it's a very interesting project and it depicts traditional architecture. Fine. And if you see that this roofing system also is very interesting, which has this truss members and this rafters, the common rafters, which are supported by the purlins, which are taking this roof. So all of this we are going to execute today in Revit. And on the basis of this section, what you infer is that there are two load-bearing walls here. See, there are two load-bearing walls, two stone walls. These are which are pretty much thick than the conventional walls, which are having this strip footing. So after transferring on the basis of this, I have transferred this entire project onto this AutoCAD drawing, and we have this particular drawing of this particular project wherein there are several considerations taken by me regarding the structure part. Wherein if you see that these two are the load bearing walls, that is 0.35 mm, 0.15 inch, sorry, that is 0.15 inch, and laying on that particular entire strip footing. And we have this eccentric footing, we have this isolated footing, we have this combined footing, and also I have given this particular step footing. All these considerations are pertaining to just a hypothetical situation wherein I have provided this just to show you the modeling skills with Revit, that how can you model different types of 3D geometries with particular Revit. Okay, and this is just a schematic section wherein you can see that this is the depth of the footing, that is 3 feet, and then we have the 600 mm, that is 2 feet of the fitting height. Okay, and this is that particular entire load bearing wall, fine, which is resting on strip footing and so on. Okay, so we will be taking the reference of that images provided by the firm and execute this particular entire project, wherein you can see that this is the schematic section which is showing the highest point, and this is the pitch on one side, and this is it's stopping here. Okay, so let's just switch to Revit, and let's say that file and new and project, and let's open up and templates and English Imperial and default project environment. Open and just open it. Okay, and just close it. Fine. So the first step after coming to this particular project environment is that we need to go to south and create this level on the basis of AutoCAD plan. You infer that there are this footing level, this particular level, and you see that we have just a G+1 structure. So on the basis of that, let's create those levels and LL, and this is going to be 3 foot. Okay, and let's just rename that and call it footing top. Okay, this is going to be the ground or road level, whatever you say. Then we have an 18-inch of plinth. Yes, and that could be plinth level. And finally, we have the first floor. And if needed, we will add a terrace level. But right now, let's just proceed on further with this. Add it. Let me just drag this all the way. Okay. And now with this levels created, right now you can see that all these levels are not appearing in proper hierarchy according to level, the way it is supposed to be displayed. And for that, what I'm going to do is that just right click this and browser organization and define a new set, calling it by level, telling Revit that segregate this particular project browser and arrange it according to level and filter by none and sorting by group, sorting and grouping and best by family and type and sort by associated level. Okay. And with that, I'll just click OK. And from all, I'll just take to by level. And with that, what you see here, that apply and OK. And you see that now it appear in proper hierarchical order according to levels. Fine. So now let's just go to the footing top. And let me just take this elevation marker a bit far away so we can have a free canvas to work on. And herein, I'm just going to go to insert and import CAD. And I'll just browse to that location where I have segregated the AutoCAD plan and differentiated it according to levels. And fine. Oh, sorry. Live classes and August, September basics. Yeah, fine. So first is that footing level. And I'm just going to say that the import unit should be inch and positioning should be manual center, place at footing level, footing top. Okay. So therein we have just placed this particular AutoCAD plan. And herein I'm just going to say that VG and import categories, and I'm just going to turn it to halftone and apply and OK. Fine for proper visual appearance. So first is that we have to start laying the footings. Okay. So let's go to structure tab, and from therein I will just lay this isolated footing first. And so no structural family is loaded in the project to load down, and yes, and if you have your libraries extracted properly, then under RVT 2024 you have this libraries, and under that English Imperial and US, and wherein you need to go to this structural foundations, and wherein this footing rectangular. Okay, there are a lot of different types of footing provided, but what we are going to use is this footing rectangular. Okay, and just open it. Fine. And first is that I need to measure this, modify, and 49 cross 56. Okay, so let's go to structure and isolated footing. And since we have loaded that, I'll just go to edit type and duplicate it and call it, I forgot the dimension, sorry, 49 by 56. Okay, 49 by 56. So isolated and duplicate this and duplicate it, calling it 5 cross 6 and 4 feet 9 inches, wherein the foundation thickness is going to be 2 feet. Okay, and the width is going to be either of the any dimension 5 feet 6 inches and 4 foot 9 inches. Okay, and with that, apply and OK, and level footing top. And yes, I am just going to place, but we cannot see it. And place, let's just place none of the created elements are visible in floor plan 1. Okay, and yeah, okay. In order to visualize that, but I just click undo. And in order to visualize that particular thing, okay, we lost that thing. So let's just define it once again. 5 6 cross 4 9. Okay, and the foundation thickness is 2 feet, and this is going to be 5 6 and 4 9. Okay, and in order to visualize this, you see that this level is footing top. So we need to give it height offset of 2 feet, that is its thickness, in order to visualize that. Just press space and I will just place it. Okay. And once placed, you just need to click modify and one and align this. Okay. Now, one thing I would like to bring to your notice that even if you snap properly, then there will be always this particular small glitch and error between the AutoCAD drawing and this Revit geometry. Okay. And that is, you don't need to worry about it. If I just click this line, then you see this snapping to this point. But even roughing that line onto that point, this is the little glitch that always visually appears, but it's snapping to that point. So you don't need to worry. So fine, I just CO copy and copy it from this point to this point. Where else do we have that size? Here and here, I guess. Here, yeah, fine. And okay, let's place one here as well. And I guess that this has lost its alignment. So just align it, align. Oh no, this is a different size, I guess. That's why it is. So yeah, so this is the different size. So just delete it. This, I guess, is perfect. So depending upon the column size and the footing may vary a little bit. So this is 5 feet by 5 6. Okay. The only this 4 columns has been taken. So that is nothing but just a structural consideration, that in order to show you guys that how to wrap the structure with the architectural element. In order to wrap structure with architecture, I have taken this 4 columns. There's 1, 2, 3, 4, 5 columns of larger dimensions in order to have this niche, so that I can show you that how can you wrap the architecture layer with structure. Okay, fine. So let me just go back to structure and that isolated column, and just once again we are going to duplicate it, calling it duplicate, and this is going to be 5 6 by 5 feet. Okay, and this 4 9 will change to 5 feet. Apply and OK, and just press space and flip the direction, modify it and align it. Okay, and that will perfectly fall in place. And CEO, and with multiple checked on, just copy it, 1 and 2. Okay, fine. We also have this another one different type of footing, but let me just check that this is modify, and is this 4 9? Yeah, fine. So just press undo. Fine. So this is eccentric footing, which is having a different dimension. So what is that? 2 9 by 4 9. So 2 9 by 4 9. So just edit it and duplicate it, calling it 2 9 cross 4 9. Okay, and this dimension will change to 2 9, and apply and OK. And this, yeah. So just flip the direction and then align it with this face and this to this. Perfect. And just this is again some different dimension, 4 9 by 4 9. Fine. So doesn't matter. Just CO, copy it, place it here and edit this type and duplicate it, call it 4 9 cross 4 9 and 4 9. All these dimensions and the structural considerations are pretty much hypothetical and conventional, the exact solution of which will be given by the structural engineer. But right now, I am here just to show you the modeling skills with Revit. Okay, so pardon me if I'm wrong somewhere, and you can rectify it. Okay, now we need to lay this particular combined footings, and what is the N9 by 5 6. Okay, so just CO and place it, edit type and duplicate it, call it 5.6 by 10 cross 9, and this length would be 10 cross 9. You can edit any of the dimension. Okay, and yes, see, okay, and just align it 1 to 2, 1 to 2. Okay, and let's just place that CO and copy it from this point to this point, and here too that the same. Yes, okay, and yeah, now we have made all the eccentric and isolated footings. Now we have to construct this particular step footing, and that, if you just go to the structure tab, then there is no option to create the step footing. So we have to create it in a slightly different manner using the modeling skills of Revit. For that, I'll just go to architecture and component and model in place. And I will just look for structural foundations. Yes, okay. And call it step footing. Name it properly, so you can find it whenever you want. And this is that we are going to create it using a different method where I'm just going to use the extrusion command. And let me just see it in AutoCAD plan that what is the, see, the total depth of this is 3 foot, okay, from that particular bottom level. So 3 foot, and yes, so I'm just going to create that particular extrusion and rectangle. And yes, extrusion start 0 and extrusion end 3 foot, and I'll just finish it. Okay, let's go to 3D. Oh, not this 3D. Right. Not this 3D. 3D of this. Okay, now, yes. So now we have to make this, convert this into a step footing. So for that, what we need to do is that just go to footing top, and let me just finish this and drop a section. Means we are going to use this as a reference. Okay, and from there in, I am just going to select this particular thing, edit in place. Okay, and I'm just going to say that create and void forms and um, void sweep. This is the command which I'm going to use, and sketch path. So this is going to be that particular path. Okay, and here we have to host a profile. So I'll just finish this and select profile, edit profile, and just go to that particular section which we just made. Okay, and this is the height of that particular and footing, and so we need to exclude. So what I'm going to do is that I will just go to this AutoCAD plan and first see that how much do we need to deduct. Yes, so this is going to be 2 feet. Fine, so I will just drop a line of say 2 feet and 12 inch, 12 inch, 12 inch, and likewise, and yes. Fine, so this is what we are going to deduct from that particular footing, which is of the height of 3 foot. Yes, that's perfect. And just finish this and finish. Okay, so that footing has been made. This footing is created. Fine, but what I suppose is that we are provided this at wrong. This is supposed to be 2 feet, and this is supposed to be 3 feet. Yeah, this is exactly at 3 feet. Then why is it? Let me see it in section once again and just finish. Oh, yes. Yeah. We need to. Okay. We have just mentioned it in offset of, we have placed it at ground level. We have placed all the footings at ground level and given it a height offset of 2 feet in order to visualize that what we are drafting. But we'll send it to its designated level once the job is done. Fine. Now let's make this particular strip footing. But in order to make this particular strip footing, this is, you see that under the structure tab, we have this footing which says that, uh, what does it says? Structural foundation, created foundations that are hosted by wall. So this is the way the strip footing is created, for which we need to create the wall in order to host that footing. So I'm just going to go to this footing top, and onto that, I'm just going to use this wall command, and therein I'm just going to go to edit type, and first I'm going to duplicate and call it load bearing wall, or let's say that stone load bearing stone wall. Let's be specific, and I know that the thickness of that is 15-inch. Okay, and just click and apply and okay. So we are laying it at the base constraint is footing top and unconnected the top constraint right now, don't worry. And with that wall finish face exterior, I'm just going to draft that particular wall. So that will come till this end, and here also it will come to this particular end. And I'm just going to copy it from this point to this point. And move it and align it properly. Okay, no, but it's not been snapped properly. So modify and align this with this. Okay. The purpose of creating this stone wall or this load bearing wall here at this point is just that we need to host the footing for this. So architecture and structure, and now I will say that footing. Okay. And with that, this is going to be that particular footing wherein we need to edit its dimension. So this is going to be 3 foot 3 inches, 3 foot 3 inch wide, just a standard dimension is taken hypothetical. So duplicate and call it 3 foot 3 inch, and cross its depth is going to be 2 feet. So width is going to be 3 foot 3 inches. Okay, and foundation thickness is going to be 2 feet. Okay, and just apply and okay. And herein I'm just going to click this particular one wall and this one. Okay, so none of the elements are visible in this floor plan. Yes, of course, because it is hosted at that wall bottom level. If I just go to 3D, then you see that that particular strip footing has been fine. So the next step is that we need to see all these particular footings at its designated level. Fine. So we will just create the columns. But before that, I would say that this is the footing and this is the structural concrete material copy. And I will just select this edit in place. And in order to perceive it as one element, structural element, I will just select this. And it is not selecting, just press tab. Yeah. So the materials copy and paste. Fine. So yes. Okay. And just finish it. Okay. Now, what we need to do is that we need to again go to footing top and just press that wireframe. Okay, so you can see the columns. Okay, and all these columns are of the same width. So we need to create this only this except this 5 columns and this 2 columns. This 1, 2, and 3, and here too 1, 2, and 3. Okay, and this I guess should connect this edge. Okay, so six columns are there, but all of these columns are same. So what I will do is that I'll go to structure, and under the architecture you have two. There is our structural column and architectural column. But first we are going to lay the structural column, and you see that it's not loaded. So again I'll go to load family, and under the same folder you have this structural columns. Okay, and under that concrete and concrete rectangular column. Fine, this is that particular column, and just open it and edit type and duplicate. Yeah, so don't do duplicate because this is the same column which the same. And I guess yes, we need to duplicate it because one of the dimension this is 9 cross 12, 9 cross 18. So this breadth is going to be 9 inch. Okay, and apply and okay. And we will just say that we'll just place it for now, and not depth but height. Okay, and height, let's for now let's just go up to plinth level. And let's just place. So you see that an attached structural foundation has moved to the bottom of the column. And yes, that's perfectly fine. And just align that properly in place. So 1 to 2, and likewise this to this. Okay. And with that, just CO copy it from this point to this point. Yes. And this. Oh, CO, and copy it from 1 and 2. Okay, and we are just going to use both of that CO copy and place it from here to here. And there's a little bit of, I get variation in this. See, even though this was snapped properly, okay, the dimension of that particular footing is different. That is 11 foot. So you just need to edit this and duplicate it and call it 11 foot, and just say that the length of that is 11 foot and apply and OK. Fine. And now just align it this face to this face. Yeah, perfect. Okay. And so CO and copy it from this point to this point and this point. Okay. This exactly seems the same dimension. You see that as soon as we construct the column, the footing is going at its designated level where it is supposed to be. Fine. Revit is moving all the structural foundation to its designated place. See, an attached structural foundation to be moved to the bottom of the column, and that is how it is. Okay, fine. And these are the columns which are of 12 cross 18. And I know that, so I will just change this to 12 cross 18. It's the size already defined by Revit. So just sometimes it doesn't snap. So it doesn't matter. Place it and then just align it. 1 to 2. And align it. Okay, and CO from this point to this point, and this point, and this, and this. Okay, but since this particular footing has been created with that function, this component and model in place, so this will not move, and we have to manually move it. Okay, while going to that particular south elevation. So see, all this particular footings has moved to its column bottom. So see, this is at the designated level. Okay, in the footing top, but this particular one has not moved. So we need to just select it, just deselect this particular two columns and move it from this point to and uncheck constraint and here. Okay, but that particular thing has again lost. We should have moved it while going to that particular. Just press undo and just go to edit in place. And now select entire chunk and just go to south elevation and move it. And with constraint uncheck, just move this particular part here. Elements will be deleted. Yeah, fine, doesn't matter. And 3D and now it perfectly appears. Okay, and just finish. And with that, these two particular columns will have a different start point and footing top with the base offset of 1 feet, I guess. Wireframe. And yeah, see, this is perfectly now. See, okay. So let's go to 3D. Not this 3D, this. Okay. So now what we want to do is that, I guess that, why is this particular one column floating? Like, just delete it. And next is what we are supposed to do is that we need to construct these beams. What are these beams? These beams are the strap beams or tie beams. I exactly don't know. that where will be its location will be, whether it will be connecting the footing or will be at the column bottom. So I don't know exactly that consideration will be taken by structural engineer depending calculating the load that is coming onto this particular footing, and then he will decide. But the point is that if those are the strap beams, then how will we connect it? So I will just show you the modeling part of that. So footing top, and again I will just go to the structure part, and herein I will just select this particular beams. Okay. And under this beams, you see that again we don't have that particular rectangular beam. So load family, and now I will say that US and structural framing. Okay. Structural framing and concrete. And this is the concrete rectangular beam. Okay. And just open it. Fine. So that has been loaded, and just go to edit type and duplicate it, calling it 9 cross 18, 9-inch cross 18-inch. Okay. And no, tie beams have to be just 12 inches enough. Okay. And so the breadth will be 9-inch wall thickness, and this will be 12-inch. Okay. And just apply and okay. And again, the depth justification is bottom. In order to visualize that, you just need to turn it to the depth justification was top. In order to visualize it, you need to turn it to bottom. And just with this, just click lines, and let me just see. Yeah, see. But the location line is, it says that Y justification is origin. You need to turn it to left or right. I don't know. See, perfect. 1 and 2. In this, it's changed. So, right. It's just trial and error. You have to do it. So in this case, it should be left 1 and 2, 1, let's see, 1 and 2, 1 and 2, 2, 3. And all this are the strap beams or tie beams. You can just change the constraint and get it at designated level. If okay, yeah, see. So let's just go to 3D and yeah, fine. Just select this one particular beam and SA, that will select all that particular beam. And right now, just change its Z justification to top, and let's say that one offset value of 1 feet. So that will exactly connect those footings at base level. Okay. So as per the structural considerations, you can just create all these beams and then lay it wherever and made it act like a tie beam or whatever. Okay. So this I guess this footing still needs to be taken at, yeah. So see, this is the newly created footing. So I just forgot to, yeah, okay, that's okay. And likewise, this also fine. And with proper visual appearance, let's just take this both of this load bearing walls right now up to just plinth level. Okay, so you can properly visualize this. And yeah, see, there are two columns which I forgot to. So let's just quickly create that. Here also there will be columns, but here the columns will start from ground level. Okay. And here this is the regular. So I would just say that column, and again, let's just edit type and duplicate it and call it 9 cross 9. Fine. And just enter here 9-inch, apply and okay. And with that, just place one here. And I seems that this has lost its location. So just move it. Okay. Yeah, that's perfect. Okay. And now wherever needed, just move from this point, or just align it, modify and align from here to here, and just copy it from this point to, it's not snapping, so just paste it here, and then once placed, you can just align it. And as I said, there will be a little bit of glitch and error between the AutoCAD. It will not exactly snap. Sometimes it does, sometimes the point doesn't. So in that case, just do that. Draw one construction line in order to get that snap point. And yes, okay. And just delete it. Okay, fine. Okay. There are columns here also, but those will start from the level above, which will have this load bearing wall as a support. Okay, that I'll show you when that point comes. Okay. Now the next part is that what we need to do is that we need to construct the compound wall first. So let's just do that. So again, let's go to footing top. And this time, instead of footing top, we will just go to ground level and herein, fine. So herein, we need to just insert and import CAD. And let's say that the ground floor layout. Okay. Preserve all inch and open. Just place it and VG imported categories and turn that to halftone as well. This ground floor, apply and OK. And now you need to snap it to the perfect location. But for that, I would just use one trick wherein this footing top for this particular AutoCAD plan, if we have anything in common, then I will just draw a line over there. And this is that common point. And I will just select this particular line and edit work plane and pick, not pick plane, but edit work plane and edit this work plane from footing top to ground level and OK. So yeah, so I guess that we'll be able to see that particular line here itself. Yeah, fine. So just move and move it from this point to this point. Okay. So we have properly positioned our AutoCAD plan and now we need to make that particular compound wall. So just go to WA wall and regular walls and just 18 generic wall and just go to edit type and just duplicate this, calling it compound wall. Compound wall. And just go to its and 9 inch. Okay. And just apply and okay. And just with this finish face exterior with unconnected height of let's say 8 feet. Just pick lines 1 and 2 and likewise and just TR join this. Okay. Now we need to lay the strip footing for this particular compound wall, which will have the auger columns at specified distance. But what we need to do is that again, the strip footing, which will be hosted by walls, and that would be of different dimensions. And for that, we need to go to footing plan and measure this. So this is 1 feet 9 inch, I guess, if I'm not wrong. Yeah. So 1 feet 9 inch and go to ground level and then structure and again this wall and select this, edit type and duplicate it and call it 1 feet 9 inch cross 2 feet. Okay. And just change this width to 1 feet 9 inch and just apply and okay. Okay. And with that, just select this particular walls. And of course, you'll not be able to see that those particular strip footing because it is laid at the level below. Okay, fine. Just go to footing top and you can see that it's placed, but it's not properly positioned. So as per the AutoCAD plan, if this is 9 inches, see, and this is the compound wall, then this is 1 feet 9 inches. Okay, so this is supposed to be 1 feet. So right now it has equally placed it. So just select this SA and all of that is selected and just change this eccentricity to minus 6 inches. And that will perfectly position it. Okay. That will perfectly position that particular footing. And now we see that our footing has been laid. Okay, fine. And that particular compound wall has been created. CC, and we can job properly visualize. Let me just change all the AutoCAD plans to halftone. Didn't turn. Yes, apply and okay. Fine. So what we need to do next is that we don't need this plan, so hide in view by category. Okay. Sorry. So now what we need to do is that we need to lay the floor plate at plinth level. Fine. So all of these columns SA and yeah, top constraint is plinth level. That's fine. Okay. But yes. So let me just go to the plinth level and you'll be able to visualize the plan, I guess. It's not there. Oh, ceiling plan, not ceiling plan, but floor plan and this plinth level. Okay, and you cannot visualize that. So footing top, not even that, ground level. And just select this particular floor plan, AutoCAD plan, and just change this work plane to plinth level. So you'll be able to visualize there. Okay, and VG, and you have to do this every time. So, okay. Now we have to construct the floor plate for this particular floor plan. And in order to do that, first is that we need to provide the ground beam or plinth beam and provide the structural ties, just as we provided the particular strap beams connecting the footing bottom at this particular level, ground level, as per the drawing. We need to provide the ground and plinth beam. So we are having a plinth of elevated plinth of 18 inches. So the ground beam and plinth beam will be one and the same in this case. Okay. So let's just do that quickly. And let me just go to plinth level and I'll just go to structure and beam. And these are the bigger beams which are having the width of 1 feet by 18 inches. So I'll select this 12 cross 18. Yes, 1 feet by 18 inches and just pick lines. And now you have to shuffle between this y justification to left or right. You have to try. So yes, see, and one and okay. So this again needs to be switched to right and here too. Yes, and okay. And here also there can be one beam, but fine, let's just provide. As per the drawing, it's not there, but let's just provide. Okay. And let's just connect this to this TR and join this to this, and this should go all the way till this point. Okay. Now let's build the intermediate smaller beams, which are 9 cross 18. And pick lines and by justification, we have to shuffle. Yeah, this has been placed, this has been placed. Okay, and this. So see here, there is a problem. So we need to change it to left. And one and two. And this will go all the way till this point, and these two beams will here. And one. See again, I need to change this to right. Okay, and then now let's just connect. So this should be right. Okay, and TR and join this to this. Connect it to this point. Yeah, this is proper. This will go all the way till here. Or let's just TR and join this to this. TR and join this to this. 1 to 2 and this all the way till this point. Okay, so that is how we have built the ground or bin beam. Let's just see it in 3D. Okay, but all of that are built at wrong justification. That justification is wrong. So just select all of that. That is, we just kept it in order to visualize this. SA, that will select all of them. Hold Control key and select this bigger one. Select SA. And with all that selected, just change this Z justification to top. Fine. So that will make properly occupy the space. Fine. So this are going to be the ground or plinth beam. Okay. And I guess that here also there will be two beams, which I forgot. So let's just quickly do that. Ground level and structure and beam. And with that 9 cross 18 selected, pick lines. And with that, I'll just snap. Yes, 1 and 2. Okay. And just take it all the way till snap here and snap it to the AutoCAD lines. Later we'll join it. So from here to here and from here to this point. Okay, now let's go to 3D. Okay, and we just need to join it with this particular stone wall, the load bearing wall, and join. Join this to this as well. All this and just switch order. Okay, and yes, fine. So likewise, we also need to join this as well and switch order. Yes, okay. So after constructing this particular beams, this needs to be connected here, connect this point. Okay, so just connect it here and go to 3D again and join one, two, multiple joins. Oh, sorry, undo and join, and with multiple join checked on, just 1, 2, and 3, and then just switch order 1, 2, and 3. Okay, fine. So now we will construct the floor plate for that particular level. Fine, this will be the plinth, which will not be the RCC, but the PCC will come at that level since that is having resting on plinth of only 18 inches from ground level. So with that filling of 18 inches, we will have the floor plate of PCC at plinth level. Fine, so let's just construct that architecture and floor plate and floor architecture and edit type and just duplicate this and call this plinth level. Plinth level, or just say that plinth floor plate, plinth floor PCC. Okay, let's be specific and edit type, and that's going to be 6-inch, 150 mm, 15 centimeters, 0.15 meters. The only difference between the slab and this PCC is that the formwork will be done and the plain cement concrete will be poured, and there will not be any reinforcement. The reinforcement will run only along the coping. Okay, I mean only along the periphery. Okay, wherein the rest only will be PCC and there will be no RCC, no reinforced steel, no reinforced concrete will be passed. Okay, and just let's quickly boundary line and let me just connect all of this. And likewise, this. And herein, I guess that we have the different floor plates. Yeah, see, so this is the washroom, and this is one homogeneous floor plate. This is also again a different. So we have to consider that. Okay, and let me just boundary line and connect this from here to here and TR and join this to this. Okay, and Just take this line all the way till here and line, and from here to this point. Okay, TR, and also this, this point. Line, and let me just draw to TR. Okay, and let's just somewhere drafting error. Yeah, so join this to this and just a finish. Highlighted lines still overlap. Sorry. Continue and TR and join this to this and finish and don't attach. Okay, let's go to 3D. That's perfect, I guess. Fine. Now, up till now, whatever we have constructed, this elements, the 3D elements, which are mostly all the structural elements, only this is the wall. But all of that, whatever you are seeing right now, is, let me just turn it to realistic. Then all of this is right now in its unfinished state and unfinished condition. Okay. Of course, this part is not going to be seen. The structure part will be hidden. So that's okay. But this is the flooring, which will have its finished layers. Okay. So in order to make you explain this, I just take you to this particular AutoCAD drawing, which is the drawing of a typical wall section, which shows the details of this particular flooring when laid at different levels, whether it is RCC or PCC, but the several layers associated to that. For example, if I just take you to the enlarged detail D of this, then you see that this is a 150 RCC slab. But on the top of that, you have this finished floor levels layers, which includes this 100 thick BBC, that is 4 inch, which is used for waterproofing. Then we have 20 thick sand bedding or PCC. Then we have 12 of thick mortar, which is the binding element. And finally, we have the 19 thick stone, which is the finishing material. Okay. And this depends from function to function and levels to levels. Okay. So we are just going to reflect that particular thing in our project. Okay. So for that purpose, what I'm going to do is that first, I'm just going to want to modify. I'm just going to click join, and with multiple join checked on, I'm just going to select this particular floor plate and join all the structural elements. Yes, and quickly I will do that thing and also join this. Okay, CC and R enter. That's fine. But I think that we need to switch order between this and this. Yeah. So this is the load bearing wall, which should continue. Okay, fine. So now we need to add layers, various finishing floor layers onto this particular floor plate, which is the PCC. Okay, and for that, I will just take you to this particular. We need to add, we first need to define the various material palettes for this. Okay, for that, I'll just take you to this particular 3D, which is the live project for last batch. And it has all the materials. It has defined all the necessary materials. So I don't want to waste time on creating the materials. Okay. And if I just go to this manage tab, and under that, if I just go to material section, then you have lots and lots of materials defined, already defined, which will just transfer while using the while using the functions of Revit, and we will make use of that. So that's why I kept this particular file open. So with that, I'll just go to 3D, this particular file, and go to annotate, and not annotate, I guess that view tab. And under that, we have transfer project settings. Where is it? Insert, not manage. Yeah, under manage, we have this transfer project settings. See, if I'll just click this, then it will open up this file. That is live project February batch, and I will just check none. and navigate to materials, and I'll just check this materials and okay. So you see that override, and with this we have transferred all the materials which were existing in that files. Likewise, you can transfer a lot of details, fine, but okay. And now if I just go to material section, then you see that all that materials which were existing in that files are now part of this files which we are going to use. Okay. And creating material is no rocket science. See, what you need to do is that you just need to create a new material that would open up this default new material. Now with this, what you can do is that you just need to, if you want to use the existing materials of Revit, then just drop this down and you should have your library extracted properly, and it has lots of existing materials which you can just make part of this particular uh, material browser and just make part of that and duplicate that, or else you can define a new material and go to this material asset and browser, and under that, under appearance library, you have lots and lots of existing materials, fine, which you just need to replace it in the asset browser. Okay, and that will occupy that, and that is how you define a new material in Revit. Okay, but I'm just not going to waste time on that, and we will concentrate on the modeling part. Okay, so with all that materials now part of this file, I'll just close this. Okay, and now what we will do is that I will just click this particular PCC, Plinth floor PCC, and just go to edit type. Fine, and under edit, first is that we need to add the structural material. So edit type, and not edit type, but here, yeah, concrete structural material, copy, and that we will just select this and edit type. And since this is going to be the floor plate of PCC or RCC, whatever it is, but 150 mm, fine. And then insert, and then therein we are going to create different levels, wherein this I would say that it's going to be since it is a ground floor, so we don't need the brick beds layer, but we will need sand bedding or PCC. See, sand bedding or PCC, and it has this graphics. Under this, you have this cut pattern of sand dense. Okay, fine, and I'll just select that particular thing, which will be of 20 mm. Okay, and then insert two more layers, and this is going to be finish one for copy and paste. Okay, now this is going to be the binding element, which is mortar. It is 12 mm, and if I just open up mortar, and you have that material already defined, see, and it is nothing, it appearance is white color because it's not going to be seen, but what important is graphics, which shows that gypsum plaster. Okay, the cut pattern is gypsum plaster, and lastly is the finishing material, that is 19 mm, and that is going to be the material of the finishing material of tile, which we are going to see, which we are going to apply. And for that, I'm just going to select this uh, this, I guess, first floor public, and yeah, that's fine. This is okay. First floor public. Okay, and just okay. And with that, apply and okay. Okay, and see that material has been applied to that particular flooring. Okay, now I'll just go to this ground level, and let's take a section, or let's just take this section and see. Just scale down a bit and change this graphics level to fine. And you see that this is the PCC, and we have your finish layers onto that. Okay, but we need to align it properly, because if this is the level line, if this is the level line, plinth level, then those layers should go above that, because those are the finish floor finish floor finish levels. Okay, so I'll just need to check this UN and length and turn it to millimeters, and okay, and modify and measure this, and this is 51. Okay, so I'll just select that particular flooring, and you see that parameter height offset built-in parameter, and I just turn it to 51 mm. Okay, perfect. Fine. So now that particular flooring has been applied, that PCC with its finish layers. Okay. Okay. Fine. So now let's construct the other parts and pieces. First is that we need to construct the ground here. So I'll just go to this ground level, and with the help of that footprints of that particular floor plan, AutoCAD plan, I'll just select architecture and floor architecture. And this time I'm going to edit type and call this duplicate and going to call it road, let's say road level. Okay. And just going to edit type and remove all this finished floor layers, because since it is going to be just a layer of mud, okay, which we are going to apply to it. And not important what thickness does it you give to it, because it's anyway going to go beyond the ground level. And let's see that, do we have, yes, mud, we have that material ready. So this was the purpose of transferring that project standards from different file, so we can concentrate on modeling, and we don't every time we don't have to waste time creating the material. Okay, mud and apply and okay. And with that I will just draft out. So first is that I'm just going to select this entire chunk. Okay, and from that I'm going to deduct whatever is not going to be part of that. So I won't have that flooring here, or actually this entire thing we just the pick lines 1 and 2. Sorry, 1 and 2. Okay, and some part of this project will also have this mud, I mean the ground, which we just need to properly tr and join, yes, and join elements. Okay. Sorry, pick lines and 1 and 2 and 3. Just a simple line. A little bit of drafting work you have to do. And unjoin, okay. Unjoin this as well. And pick lines and pick this as well. TR and join this to this. Okay, and that is how you create this particular. And also here we will have that. So I just need to draw some lines. This line is snap to wrong. Okay, fine. From here to here. And likewise from here to here. And just say draft split and join this to this and this to this. And also this will have that. Okay, highlighted lines overlap. So TR, and we need to have a close shape. Fine. With this, if I just say that finish, something always remains. Yes, TR and join this to this. And fine. And this line will actually be at this point. Yes, sorry. And just finish. and join this to this, and we need to have a close shape. So a couple of lines I forgot to join. Finish. Oh, still, last one. Okay, and just finish. And yes, finally, 3D. Okay, so that particular layer is appearing at ground level and R enter. Yeah, fine. So this is the ground, and let's construct the another parts of this particular floor plates. But before that, I guess that this particular beam should connect here at this point. Yeah, fine. And let's see it in section. Okay. And if I guess that I had made some mistake. Yeah, fine. So we have taken the consideration that the slab will not be casted on the ground floor and this will be PCC, so there will be no layer of PCC here. And I will just get rid of this particular layer. And here, yeah, this would be the PCC, the floor plate of PCC. Fine. And yes, okay. And the reinforcement will be along the periphery. Reinforcement will be passed along the periphery. Okay. That was the only one change, which I guess that was left. Fine. So now let's construct the another parts of this particular flooring as per the AutoCAD plan. So this is the private areas and this is the wash. Okay. So let's first do that. So let me just go to length level again. And herein, I would say that floor architecture and duplicate. Actually, let's select that one, Plinth level PCC, and duplicate that. So we can make use of the existing layers and would say that Plinth floor private. Okay, and edit type, and everything will remain the same. Only this particular material will change, wherein we are going to use different material. Fine. So this is the material that we are going to use, or let's look for something else. Applying material is not important that much, that you can render it later in any of the Enscape or any other engine. But where is that? Yeah. Okay, let's just apply this material for now. First floor private, yeah. And okay, apply and okay. And let me just from this point to this point, and from this point to this point. Okay, and just finish and don't attach. Yeah, fine. Okay, at the same time, let's do the wash also. So floor and floor architecture and edit type and duplicate and call it washroom washroom floor plate. Fine, and just go to edit and everything will remain here the same except for this would be wash. Let me just upper ground wash tiles. No, and yeah, let me just select this particular thing. Fine. And we have to lay this particular flooring in a such a way that there will be one tile drop. So we have to reduce the any of the layers herein. Okay. So let's may just keep this 10 mm. Actually, that should be 12 mm. Yeah, fine. And okay. Apply and okay. And rectangle and the here to here. And likewise here to this. Sorry. And just finish it and don't attach. And I guess that I snapped the wrong line here. So finish, don't attach, and then edit boundary, and yes, don't attach. And let's see it in 3D. Okay, so this left, edit boundary, and again go to plinth level, and this was left, don't attach. Yes, fine. Okay, and let's just join them, modify and join, select the floor plate, yes, and yes, join, and okay. Why is this not joining? Uh, yes, and yeah, you need to be very careful. Join, and once again, let's check the multiple join. Join, and sometimes it's create problem, it doesn't snaps too. So join and select this and this. Yeah, okay, that's fine. CC R enter, join this as well. With multiple join checked on. Select this floor and 1 and 2 and 3. Okay, and join and CC R enter, join and 1 and 2. That's perfect. Okay, here join and 1 and 2, and likewise join 1, 2, 3. That's perfect. And this needs to be okay. CC R enter, and I guess here there is a problem while snapping. We have snapped to wrong line, I guess. So let me just go here. No, it's perfect. Edit boundary, and yeah, don't attach. Go to 3D. Why is it okay? Since those particular beams are the bigger beams, so that's why. So it doesn't matter. Just actually, this should continue till this point. I made a mistake. Sorry. Edit boundary, and go to ground level, and this should continue here till here. Yeah, that's fine. And then let me just check whether everywhere else it's fine. And don't attach. Okay, and let's go to 3D and join, join again. Yeah, CC R enter. And this particular private, then why is it reading a different thickness? There shouldn't be a gap over here. Height offset 51. Yeah, we need to give this flooring a height offset of 51 mm. And then it will flush 51 mm. Yes. So before proceeding further, let's just check this particular thing in edit boundary, and this will, let's just delete this HL TR and join this to this. Don't attach. Yeah, that's fine. Before proceeding further, let's have a check in section. That is everything keeping up, putting up fine. Yes. And okay. The only thing is that here I guess we need to switch order. Yeah, fine. For every beam which is getting cut, join and switch order. Okay, perfect. And we need to check this at multiple places in plan. Let's check it here. And yeah, that's better. That's fine. Okay. Let me just take this section here. Join and switch order. Join and switch order. Okay. And here this is not joining. So here, join and switch order. That's better. Okay. Now, what next we need to do? Here there seems a problem. That's not actually a problem, but let's just see it in, and let me just go to this section and yes, so join and okay, and join and switch order. And likewise here too. Join and switch order. Okay, let's take a horizontal section as well. 1 and 2. Join and switch order. And fine, and just reduce the scale a bit. You can view properly and see in this particular section as well. We need to switch order. Good that we took that particular section. Join and switch order. 1 and 2. Switch order. 2 and switch order. And finally, the last one, switch order and switch order. Yeah, okay. And take this section here and let's just check the join condition and switch order. You might be wondering that what is the need of doing so much of hard work, but this is very necessary, very essential in order to properly quantify, and the joint connection should always be perfect. Sorry. Yes, and again go to ground floor and just check join and switch order. Switch order, switch order, and switch order. Okay, and yeah, that's better. That's fine. So now we have perfect join condition and everything. Yes, so now let's create another parts. Yes, let's just create this entrance quota, entrance deck, and for that let me just go to ground level. And yes, floor, floor architecture and floor architecture. And this time Plinth floor PCC and edit type and entrance deck or entrance foyer. Okay, and just go to edit type and we just need to change this material, wherein I'm just going to say that mm, yeah, you're going to apply this material for that. So just say OK and OK, entrance foyer and apply and OK. Yeah, and just create that rectangle and deduct 1, 2, and 3. Actually, we should have not created the floor plate, but we should have created this entire thing by a different method. So let yes and extrude and under flooring, floor architecture, and I hope that we haven't created that. Yes, that's fine. Okay, and let's just create that by a different method, wherein I'm just going to say the component and model in place, and this should be floor, floors. Okay, and fine, and just say that entrance or let's say that hardscape. Yeah, hardscape. That's okay, fine. And we are going to create this with the use of extrusion command. Okay, and fine, 0 to 6 inch finish and create extrusion 0 to 12 inch and then create extrusion this entire thing and get rid of TR and join this to this, and this will be the flower bed. So again, I need to make this changes. Okay, okay, and this would be 0 to 18 inches. Fine, and just finish and select all of this and change the material and apply the same material, plinth, finish flooring public, and this material. Yeah, finish. And let's just see it in 3D. Oh, that's perfect. Fine. And we have a one tile drop. That is absolutely perfect. Okay. Yeah, see. Now we need to create and this material should be different, I guess. And let's apply, uh, where is that stone material? And not that. South wall. Let's apply this material. Okay. And here, let's create. So again, go to ground floor and create an extrusion. And that would be just delete tr and join this to this. And its height would be 18 inches plus 3 foot. So 4 feet 6 inches. Or let's say that 18 inches plus 18 inches, 3 feet is enough. Okay. And apply it a material of wall. And finish. And herein we need to create the flower bed. And that would be just a small sliver and small extrusion of starting from 18 inches and going up to 18 foot 6, 18 plus 6, that is 24 inch. Or let's just say that 20 inch, 2 inches, fine. And that would be grass. Okay. Okay. And just finish. 3D. Okay. And this, I guess, should have an extrusion of, it should be 18 inches plus a small sliver. So let's say that 20 inch, that's fine. And this should go down 6 inch and 12 inch. Okay, that's better. Fine. And the same particular thing will come here as well. So let's go to ground floor and complete it. So create an extrusion from this point of rectangle and this point. And join this to this. Okay, and 0 and 16 inch. That's fine. 18 inch is also better. Then have one tile drop. And this entire all these things will be done by uh, what do we say? Filling. Filling will be done, and this particular thing will be achieved, and all that we'll have the flooring. But that's fine right now. I'm just first floor public, and where is that? Plinth, yeah, okay. And here too, TR, and join this to this. Okay, and just finish. And also we have a small pool over here, so let's just create that as well. And split lines. And yes, 0 and 20 inch. Okay, and then just like that grass, we need to create one extrusion, which would be the base plate, and that would be 0, and just 12 mm tie, which will be resting on ground on PCC, and wash. Okay, finish, and then just go to section 1. We cannot see it in section 1, but probably this particular section, and then which one was that? 3D, edit in place, yes, and go to that particular section, yes, and just copy it, and copy it from this point to this point with constraint and check, just copy it here, and this would have the material of water, which is the existing material of provided by Revit, and just finish and 3D, and yeah, so see, complete. And I guess that this particular plinth will have a height of 12 inches. That is one step down from this particular flooring. And then you'll be able to, yeah, fine. And also this, what material has been applied to this south wall. So just copy and select this and paste. Yeah, that's okay. Okay. And if you just see that some of the places there is a small glitch or error of this particular join, the one which we did in section, also we need to do it in 3D. Okay, so I will just temporarily hide this particular compound wall, SA and HH. Okay, and then we will just join this particular thing first perfectly and resolve the glitch wherever it is there. So join and switch order, select this and this. Okay, again join switch order. This should be join here, and join switch order this column up till this point. Yeah, that's fine. CC R enter, and just see the small glitch remains. So switch order. Yeah, fine. CC R enter, and join switch order. This is creating a problem. So let's just unjoin the geometry for now. Okay, and then join it again. Join this flooring with column and with beam, and then CC R enter, switch order, yes, and sorry, and switch order, perfect. Okay, let's just see that where else that particular thing. Okay, this also has lost its connection. So join and switch order, CC, switch order. Okay, yeah, fine. Where else? Yeah, here too. See, all this is very important in order to properly schedule and quantify. So we need the perfect join condition. Control Z and join and switch order. This to this. Join and switch order. Okay. Where else? Here. See, fine. So join and switch order. This column with this. Okay. Here too. Join and switch order. And we are getting it perfect at all places. And join and switch order. CC, R enter, CC. Yeah. So switch order, and this is not join only. So join with this, join this with the column, yes, and then switch order, okay, switch order, and switch order, fine. Let's have a check here. So here everything is perfect. Yeah, so done. Okay, yeah, only this particular one column. So join and switch order. So this are the drafting skills with Revit. And if you don't do this, then there is no point working with Revit. You need to be very precise and perfect while modeling. Okay, so just R enter, HR. So what is the next step? I forgot to provide this particular steps. So let's just quickly do that. And there's not a big deal for doing that. So let's edit in place and quickly create extrusion and one and just CO and copy landscape steps 1, 2, 3 with multiple checked on. And here too, but here the size is different. So CO and one real quick and that would be again 0 to 12. Okay, 0 to 12. Yeah, that's fine. And let's give it a material of which material has been applied here. So we'll change the material once which material is applied. South wall. Yeah, fine. Copy and not 12. I think it's 12 inches. Yeah, fine. Or let's keep it 6 inches. That's enough. Okay. And just change the material to, yeah, same. Fine. HH. And yeah, fine. Edit in place. HR. And I guess that missed some edit extrusion. Move and move it from this point. Yes, and 3D. Okay. And we are completely done after so much of hard work. Just being able to create. And let's have one PCC layer here also. So create an extrusion, parking, parking floor, and not 6 inch, 75 is enough. Oh, sorry, 75 mm. And what material you will provide? It's not an important material part, but parking and backyard. Okay, let's finish 3D. Um, First floor public and Ramp material. Yeah, let's provide ramp material to that. Okay, fine. So after so much of hard work, we have been finally able to complete this ground floor perfect with landscape part. And now let's start constructing the walls. And in order to do that, first is that we need to elevate the structure. Fine. And that is very efficiently done in Revit. If I just select this everything, I usually see that we have a very powerful command here, filter, and I'll just check none. And I will just select the structural columns and apply and OK. Fine. So these columns are selected and you see that the base level is footing top and top level is plinth level. I'll just change it to first floor. So with one click, we have just elevated all our columns to that designated level. Fine. And now we need to select the structural framing. Okay. And for that purpose, what I will do is that I'll just go to this particular south elevation. And herein, I will just select this particular entire chunk and then filter. And I'll say that check null. And then I'll just select the structural framing, apply and OK. And with that, I will say that copy to clipboard and paste align to selected levels. And I will just paste all of them to first floor. Okay, so all of them have been elevated to that level. We just need to properly position them. Okay, and for that, I'll just go to south and select all of that and say that the end, oh, sorry, the Z justification to bottom. Oops, not bottom, sorry, top. Yes, and select all of this and say that the Z offset value, I will say that minus 18 inches. And fine, and just go to 3D and you see that our structure part has been properly elevated to that particular designated level. And now is the time to start laying the walls. Okay. But before that, I would just like to select this SA and this compound wall. I would just give it a material. We can differentiate it and compound. I guess that already that material is defined. Compound wall. Yeah. See. Okay. And you can just apply. Okay. Apply and okay. Fine. Now, next is that now I would like to bring to your notice that this particular wall, south walls, this walls can also be just taken above by changing its constraint. A south wall, sorry, load bearing walls. The load bearing wall, if I just change its constraint to, let's say, first floor, then those walls will go up. But as for the AutoCAD plan here, this particular south wall, this particular structural load bearing wall is hosted with this particular strip footing. Okay. This is the footing which we had made it structure, and you see that this is the footing which is hosted by that particular wall. So, and as per the plan, if you see that wireframe, and here we have a normal wall. See, this particular load bearing wall on upper level is getting converted into the 9-inch regular wall. Okay, and here also there are two columns which are getting hosted onto that particular strip footing which we have laid for that particular this load bearing wall. Okay, the stone wall, structural wall. So what I'm going to do is that I'll just go to 3D and undo, and I'm just going to draw another walls on the top of it. And right now, what is the constraint? Is plinth level. So I'll just go to plinth level and construct two more walls, but exactly where it is needed. So I will just say that wall, and where is our 15-inch, yeah, load bearing stone wall. Fine. And I will just start from here and continue till this point. And just like that, here too, I'll start from this point and end here. Okay. And just select, go to 3D, select both of that walls, and it's unconnected. I will just take it to first floor. Fine. And give it a material first so we can differentiate it. And herein, I'm just going to create a new material. Create new material and rename it, call it one stone structural stone wall. Okay, and while I just go to this particular asset browser, appearance library, and here we have that stone, and here is that material, fine, masonry stone, and I will just replace that material. So that material is now part of our asset browser, and just information, I will just duplicate it. The purpose of duplicating is that if you don't mess up with the system families, and that will give it a same name, structural stone wall. Okay, and let's change it tiling or sample sizes this. So let's change it to 4 feet, 4 feet by 4 feet. Done. Apply and okay and okay and apply and okay. Fine. So you see that now it resembles with our structural wall, the load bearing structural wall that is provided in the image. Fine. So, okay. And with that, now what we need to do is that construct the wall here. But before that, I would like to bring to your notice that the walls, this particular wall is a structural stone wall. So it won't have any layer to it. But the regular walls now, which we will draw, should have the layer of plaster to it in order to hide the structure. See, I'll just show you. If I just go to this particular plinth level and WF wireframe and wall, and herein I will just select this wall and go to edit type and duplicate it and call it main wall 9 inch 230 mm 23.23 meters 23 centimeters, and herein also I will just enter its thickness to be 9 inch, and here I will just apply this main wall. I guess that material is already there, or just and wall material is not there. Ah, yeah, wall paint. See, okay. And I will just give it under graphics. You see that I have given a cut pattern with something resembles like our AutoCAD view. While going to here, new fill pattern, and you can load the AutoCAD hatch pattern also. But right now, I'll just use this which resembles like AutoCAD cut pattern of wall. Okay. And with that, I'll just say apply and OK. And herein, I will just draw a wall starting from here, press tab and flip the direction and draw walls. Okay. Now, if I just go take it to this particular 3D, then what you see is right now, this wall is overlapping with the structure. Fine. So if I just go to this plinth level or ground level, no, we drew it in plinth level. Fine. So let me just change this to fine. Okay. And for proper visual appearance, let's hide the AutoCAD plan. Now, what I'm going to do is that modify and join. Select this structural column, join it with this wall and this wall. Okay. And join and select this structural column, join with this wall. And now let's go to 3D. So this is the exact way. Also join this. Okay. So this is how the construction will happen. That this will be the masonry work. But when the construction is takes place, you never see this particular structure. So how to do that particular thing in Revit? Fine. So therein, I'm just going to select this particular wall and edit type and edit. And I will just insert a layer, finish 1 4, and this should be insert down and finish 1 5. Okay. And this, I'll apply a material I've already defined last year, which is exactly like a wall paint. Wall paint color has been applied, same color, and under graphics, I have unchecked the foreground pattern. Okay, because this is just a small sliver of 12 mm, point 5 inch. That is point 0.5 inch, and copy and paste and point 0.5 inch. Okay. And with that, I'll just click OK, apply and OK. Fine. So now what you can see is that I'll just go to ground level and no, not ground level, plinth level. Fine. So you see that the layer of plaster is now added to this. Fine. So just delete this, both these walls, actually all the three walls. Fine. And then just go to WA and select that main wall. And with this base constraint to plinth level and this location line, I will just change it to core face exterior. And I will just start drafting. Okay. And I'll draft from this point, and this will be the complete wall, I guess. Press space and you can flip the direction, and HR, AutoCAD Plan, in order to see the walls. Okay, and here, let's just continue till here. Anyways, it is going to get hidden. And fine. So just like that, now we have this internal wall also. So just select this edit type and duplicate and call it internal wall 4.5 inch. And everything will be same. Just go to edit and change this to 4.5 inch. Okay, apply and OK, and WA, and with the same constraint, just draw from here to here. Press tab. Oh, main wall, internal wall, and press tab. Yes. Okay. Now, even if you join, see, join and join this structure. Watch this point. Watch this point. I'll select the structural column and join the wall and this wall. Just like that here. Join and select the structural column. Watch this point. This wall and this wall. And just like that everywhere. So join structural column 1 and 2. And join 1, 2, and 3. Okay. And join. Oh, sorry. Join and select the structural column. Fine. Okay. And with that, now if you just go to the 3D, then what you will notice that the structure part is hidden and the layer of plaster has been wrapped. Okay. Fine. Okay. But you can see that this particular wall, oh my God. So just select this wall, SA. That will select all the walls, and top constraint should be first floor. Fine, perfect. So just like we joined the structural columns, also we need to join the structural beams. Okay. And I'll do that in 3D itself. So select this particular structural framing, watch this point, and then the wall. Okay. Just like that. I'll just uncheck this multiple join and structural column with the beam and join. Okay. And join all the structural beam with the walls in order to have the perfect joint condition. Yes, fine. And this two walls, I guess, internal walls. So again, that too, first floor. And how is that internal wall was? Uh, we have a main wall here. So just change this to main wall 9 inch. Okay. And I guess that the location line plinth level. And yeah, it's perfect, I guess. Press space. Uh-oh. And the beams are, I guess the location of beam is wrong. Mm, go to plinth level And the wall is perfect. So the beam has been placed incorrect. So let's go to ceiling plan of plinth level. And yeah, see, that is what I was wondering that why is it showing that? Yeah, perfect. I'm going to just close this and go to 3D. Okay, and then join the structural framing with the wall. Yeah, perfect. Okay, now the purpose of creating this beams, giving this particular beams more depth. You see that this is 12-inch cross 18-inch, and also the columns here, I guess, are yeah. See, so the purpose of giving the bigger dimensions to this particular structural columns and this column is also 12 cross 18 and this beam is also 12 cross 18. Otherwise, rest every other column and beam are regular 9 cross 18 and 9 cross 18. See, but the purpose of creating huge, bigger dimensions for this columns was that I purposely wanted to show you that when you have such columns and beams which are popping out, which are extruding out of the wall thickness, then how to hide this particular structure. Fine. So in order to do that, I will just go to plinth level and herein you know that this column is 12 cross 18. Okay. So I will just press WA, also not WA, go to architecture and under columns, you have along with the structural columns, you have this architectural columns. Okay. And just go to edit. And if you want half inch to be wrapped, this is 12 cross 18. So I'll just duplicate this and call it 13 cross 19. So half inch of plaster on both the sides and 19. Okay. And the depth should be 13 inch and the width should be 19 inch. Okay. And apply and okay. And with that, now you see that you can essentially host that particular, just select this snap, just snap to the, or just place it outside somewhere and then modify and just pick align and pick this to this center to center. And just like that, also we need to align and snap to, yeah, center of this to center of this. Okay. And you see that the column has been perfectly wrapped. Fine. And you don't see that structure part. Only thing is that join and select that particular structural column. And yes, see, watch this point. It should read structural column 12 cross 18 and then join it with this. Perfect. And then just like that, beams and yeah, okay. And you see that our layer of plaster has been wrapped onto that column. Okay. And you cannot see the structure part. And don't worry about this face, or the walls, the layer of plaster will merge with this particular external layer. Okay, because that architectural column also has, yeah, we need to apply it the same material. Let's say that plaster. Yes, so that will merge with the external plaster layer. Okay, so just like that, we need to copy this particular thing to Plinth and we need to copy it from center of this to this, this, and likewise this. Okay. And we need to join the geometries. So I'll go to 3D and real quick, I will just join and select the column, structural column. Watch this point. It should read the structural column and then this and join again with this beam and this and join and this to this. Okay. And likewise, join structural column with the plaster, join and beam, and at all the junctions wherever needed, and fine, and join and structural column, plaster, join this. Okay, perfect. Okay, so the wherever the structural columns were there, the layer of plaster has been wrapped. Okay, but what about this beams? How to deal with this particular beams? Because just like this architectural column, under the architectural tab, you have this column, structural column and architectural column, but we don't have, just like that, we don't have architectural beams. So how to deal with this? So in order to do that, what I will do is that we will create a false wall and edit type and duplicate it and call it beam wall. Okay, and everything will remain the same except for this thickness will go to 12 inch. Okay, because the width of the beam is 12 inch. Okay, fine, and just apply and okay. Now it is very important what constraint you give. So in order to wrap this particular, the depth of this beam is 18 inches. So what I will do is that I'll give it a base offset of 8 foot, 5.5 inch. Okay. And with that unconnected knee, first floor, what I will do is that I will just pick lines and I'll just snap. Shouldn't root this particular error. I guess that we have made some mistake while, let's go to south. And let me just change this UN and let me just switch to feet and fractional inches. Okay, and okay. And see. So yeah, this is the error. The error is that I placed that particular level at 8 foot 6 inches. So you just need to give it a height of 10 feet. That is standard floor height, 11 foot 6 inches. Okay. And you see that all the elements which have been constrained to that first floor will elevate at that point. And we might have error for some beams. Select SA, and I guess that we had given, yeah, we gave it a offset of minus 18 inches. So let me just change it to 0 and that will do the job. Okay, fine. And yes, everything is perfect. Okay, SA, and also this to 0. Yes, we had joined it, so that's why. But anyways, yeah, we'll do that again. Doesn't matter. Fine. Everything is perfect. And base offset this particular wall, plinth, and not unconnected, but first floor. Yeah, okay. Just join this to this. Okay, fine. Not an issue. And now with this, if I'll just say that WA and with that beam wall and base offset of 8 foot 5.5 inches and first floor, it should read this unconnected height 1 foot 6.5, and then I'll just pick lines. And with this, yeah, so we just need to change to core face interior. And yes, one, two, just flip the direction by pressing space. That's okay. Just select this and, oh, sorry, too fast. Space, yeah. So one element is completely within the another. That's okay. WA and again pick and this space. Okay. Likewise, WA and pick. Let's just place them all, and that will pop up an error. A lot of errors, but yeah, that's fine. Select that SA, or sorry, not SA 1, 2, 3, and 4. Not this one. Shift and just select this and change all of that. Just space, okay, and that will perfectly occupy the space. Okay. Now what we need to do is that join the geometries again. So join and select that, read this, watch this point, and it should read, press tab, and it should read structural concrete framing with this wall. Yeah, so just like that, press tab, structural framing with the wall, framing with wall, framing with the wall, framing with the wall, and yes, and you see that we have the perfect join condition and you don't have your structure visible anywhere. Okay, so this is how you can work efficiently with Revit. And here this still remains. So join. Okay, and fine. So this is the line you see here, but that's fine. The layer of has, and if you want a clean connection, then select all of this. You need to join this also, this with this. Okay, and yes, this with this wall and this. Okay, and we have one uniform surface. Join, and this is just one-time work. With this, you'll be properly able to quantify and schedule everything and perfect. Everything will go. But CC and join. Come on. So selecting that wall. Yeah. Okay. And join this. Yeah. See. Okay. And yes, one more remains. Join and this with this. Okay. Still this one line. Okay. And you see that you have a uniform. Fine. And just need to drag this beams and connect it to that load bearing wall perfectly. Okay. Yeah. So R enter. Yeah, realistic. Fine. Okay. Next step. What is the next step? The next step is to, so just like this particular beam wall, and here we need to wrap the layer of plaster. But before that, let me just make this couple of walls, one and two and three, and just couple of walls. Let me go to ground plinth level, and that will elevate from where. So the top constraint is plinth lag. So at least we have base till plinth, and go to plinth level and WA, and this is again going to be the main wall, 9 inch, and I will just duplicate it since I want to apply a different material to it. Let's call it main wall 2. Yeah, fine, that's okay. And edit, and instead of plaster, I will just give it a different material, maybe south wall. No, not south wall. Yes, load bearing wall. That's fine. Okay, okay, and okay, and apply and okay. I'll just create that particular wall with 0 and up to first floor. So unconnected reads 10 foot, perfect. And from here till this point, press space and, likewise till this point and here. Yes, okay. Yeah, fine. Enjoying. Doesn't matter. And likewise, draw here that wall as well. Press space. And yes, okay, done. And 3D, and select that particular wall and edit type and copy and paste. Okay, apply and okay. Okay, fine. And just go to that level and just unjoin this. Yes, can't keep element join. So just go to just join condition and disallow join. Yeah, so that's fine. And now you can take it outside. Okay, perfect. Okay. And here there are columns also, which we need to draw. And also this and disallow join, and just drag this all the way here until it snaps to that. I'll just pull it out and just trim and join this to this. But we said that allow join and allow and tr and join. So yes, these are the drafting skills. If you want to learn all this in detail, then enroll for this course and we can learn together and grow together. Just like this. Here too, we have 3D and okay. And let me just first, yeah. So see here also that particular compound wall. And let me just go to ground level and first take that wall outside somewhere. Yeah. And then connect it. But that will go inside. So wall joint and disallow joint. Just take this wall outside and this here, and then say that allow and tr and join this to this, and we have perfect. Okay. 1 2 sa h, and you if you see that we'll have the columns also over here. Fine. So which will elevate from this level. That's not important, but I just like to go with the AutoCAD plan, and you see that there are two columns over here, 9 cross 9. So I will just say that structure and column, and with the 9 cross 9, yeah, that's fine. Going from and just place here. Oh, sorry. This should be height, and height should be up to first floor. So 1 and 2, and here too we have that 3 and 4. Okay, and then with this selected, all of this SAHH, hide it and just modify and align it with the AutoCAD lines. Press M, enter. Okay, and here there is. So what is yeah, concrete? Then why is it not showing that hidden line? Scale is, I guess. Okay, yeah, fine. So now we can properly visualize that. M, enter. M, enter. And align. Let me just place it somewhere over here and then align. Here we don't have any lines to snap to, so that's why it does not. HR and wireframe. Yes, okay, okay, fine. So just what we need to do is that go to 3D and okay, the structure is complete. We also need a beam over here, but that's fine. We can just ignore that. Okay, so I'll just join and select that particular column and watch this point, join and select that column, structural column and join. And just like that, press space, structural framing and join and structural column and join. Yeah, perfect. Okay. And we have the perfect join condition and perfect. Everything is perfect. Okay. And likewise here too, join and structural column with the wall, structural framing with the wall. Press tab, structural framing with the wall and structural column with the wall. Okay. Fine. Okay. Now we will have punctures onto this particular wall. So how to do that? We can just select this particular wall and say that edit profile. And randomly, I will just create HL and I'll create some punctures and CO and with multiple checked on, copy CO and copy it from here to here. And likewise, you can copy this to here somewhere. Okay, and just finish. And you see that we have the punctures. Okay, just like that. This wall too. Date profile and HL and just a simple rectangle and CO one and oh, that's too far. Copy just one CO and copy from this point to this, and select and just move and CO, copy it from this point to this point. Fine, and just finish. Okay, R enter. Okay, that's perfect. And herein, you just select this particular one wall and SA, that will select the chain of walls. And I don't need to see this particular structure part. So what I will do is that I'll just change this base constraint to ground floor. Okay. So that will, with that, all the structure part is hidden. Fine. But again, we just need to join them. Okay. So what we need to do is that join and select that beam and this wall. Fine. So you only have, okay. Now, after this wall is laid, you also need to join this to here. Fine. So in order to finish flooring layers. Okay. And we have done it here, which is this section. And this is section two. No, this is section one. Okay, fine. So here too, I guess we need to join. Yeah, fine. So join and structure, or sorry, join and beam and with the wall and this to this. Okay, and you see that only the layer of plaster get wraps. Okay, and join and switch order. Yes, perfect. Plinth level, and again just take this here. At all junctions, we need to do that. So join structure with this to this, and join and switch order, and this to this, and masonry should come to this. Okay, fine. Here too, length level. Yeah, join and switch order. We did this, but only the thing what left was this. And here too, join and being, yeah, so here only the flooring needs to be joined. Join and flooring with this and switch order this to this. Okay. And 3D, oh, sorry, not 3D, ground floor. This is proper. Just a cross check of whether okay. And here too. Okay, perfect. And now ground level and just take this particular section here and just see it, join and structure with this and this to this and switch order. And just like that, this to this, oh, sorry, join this to this, this to this to this, and switch order and perfect join condition. Masonry will come till this point, join and this to this, and join and switch order, this to this and this to this, switch order, perfect, switch order, yeah. But then this is creating a problem. Okay, let's just ignore that. That's okay. Join and switch order and perfect. Okay. And ground level. And let me just go to this section. And yes, we have already joined that particular thing, so we don't need to worry. Washroom floor plate. And yeah, that should have a one tile of gap. So in order to do that, I'll just press UN and again switch to millimeters, and this is the best part of Revit. You can switch between working units anytime. And this is having 12 and 19. So what I will do for this washroom floor plate is that, yeah, it's already provided a drop, then whatever issue. Uh, yes, so move and with this join, I will just place. This should be given only the offset of, I guess, 24 and no, 12 and 12, 24. Yeah, that's fine. So that's why that's 24. Yeah, so this now we have one tile drop. Oh, that's perfect. Okay. And just go to ground level, 3D, and yeah, everything is perfect. Now let's construct the other walls for this particular floor and just finish off the modeling part of this floor. So ground level and not ground level, plinth level. And as per the reference image, you see that here we will have, let me just show you. So this is that part, living room, which you see that here there are no walls, and here there are the sliding folding doors over here, and sliding window over here, which is leading to that particular staircase, which is on outside. And here also, you see that this particular structural wall has don't have, and we have a see-through in the kitchen area. Okay, so we need to do all these things, particular essentially. So let me just switch to Revit again, and what I will do is that I will just go to WA and select this particular main 9-inch wall, and from plinth level to first floor, and just draw this particular wall over here. Okay, and likewise, I will draw it here also. But herein, I will not draw that wall. And what I will do is that I'll go to architecture and column architectural, and we already have that particular column. So what I need to do is that just duplicate this and call it 10-inch cross 18-inch. Okay. And herein, for the depth, I will just change this to 10-inch. Okay. Apply and okay. And then modify and align this to this, and likewise the center of that, uh, align, and this to this. Okay, and we have perfectly placed it. Okay, and this column is already wrapped in that wall, so don't need to worry. And one more thing, I'll just go to 3D and WA and just select this beam wall. Where is that beam wall? But there we have entered the thickness of, if you remember, 1 foot. But now we just need it. So again, we need to duplicate this as well. So duplicate and beam wall 2 and edit it and call this 10-inch. Okay. And just finish, apply and okay. And plinth level 5 8 foot 5.5 inch and up to first floor. So the unconnected will be 18 inches, and that's fine. You can switch between units and get cross check, but I will just snap. Okay, and that wall has been created. Only thing is that I need to go to ceiling plan. And there are a lot of drawings open, which I think that not needed. So ceiling plan of plinth level, wherein this beam wall, and it's not showing wireframe, and why is it? This should be beam wall too. Yeah, that's fine. And thickness is UN, and let me just switch back to feet and fractional inches, nearest to 1/4 of an inch. Okay, and okay. Fine. And if I just select this particular beam wall, then it's the 9. Yeah, the layer of plaster is already added, so it should be just 9-inch. Okay. So fine. And apply and okay. So now that will perfectly, and just connect this to this point. Okay. And just see it in 3D. Oh, perfect. Okay. What we just need to do is join couple of geometries, wherein first is that I want to join this and this as well. Join and just get rid of this and join and switch order. Okay. And join and switch order. That's fine. Perfect. Join and this structural beam, tab structural framing with that wall, structural framing with the wall, and yeah, and likewise here too, structural framing with the wall, and yeah, perfect. And here too, structural framing with wall, and yeah, perfect. No issues. And now let's construct the wall for this part, which would be very easy. So because we don't have the beams or columns elevating out just like this, so that will be wrapped, and we can just quickly go to plinth level, not this plinth level, and plinth level floor plan. Okay, and WA and main wall 9-inch where it is, and the base constraint to be first floor, ground floor, and base offset to be 0, and top constraint to first floor. And let's find 1 to 2 and 3, just like that over here also. And yes, highlighted wall overlap doesn't matter. And press tab and connect this to this. Press space and connect this to this. Okay. And this is already, yeah, fine. Okay. And here also we have a wall up till this much. So a lot of geometries to join. And for that, I'll just hide the AutoCAD plan and then join. Select the structural column and this wall. Oh, sorry, it's not overlapping. So we'll just join this. Yeah, fine. And join column with this wall and column with this wall. Yes. Wireframe to HL. Yeah, that's perfect. And join column with this wall, this to this to this. Yes, we are done. No more geometries to join and just go to 3D. Yeah, we have to join it in beam also. So select this structural framing and wall, framing and wall, framing and wall. I'll be pretty much fast now. And framing and wall, framing and wall. Yeah, fine. So this is remaining. So let me just do the needful. Okay, and now you see that there is no beam over here. There should be one beam. So it doesn't matter. Just CEO, go to plinth level and ceiling plan of plinth level. And with this beam selected, just CEO, copy it from this point to this point. Okay. And just drag it. No, delete. And I guess that we will have a beam over here. And that beam should actually continue. Where is it? Yeah, here. So this beam should continue all the way till so plinth level and connect. Okay, that's fine. Just go to 3D and just join this. Okay, and switch order. Okay, and urine join and this to this. Okay, and we need to create a wall over here, but that's okay. What we can do is that we can just CO and copy that particular wall to this portion and just yeah. And the constraint we will chain 8 foot 6.5 5.5. Okay, and it's not visible here, but will be visible in, yeah, fine. So just join it and perfect. Okay, and go to 3D. Yeah, see, and okay, done. Fine. And now we need to deduct this particular wall. We need to cut it in a such a way that it should resemble this, see, this particular thing. And because from here there will be again normal wall, on the upper floor, normal wall. See, I'll just show you. See, this is that. No, see, this is the junction wherein down you have this structural wall, and on the top of that you have the normal wall. Okay, so this image is not clear properly, perfectly, but you can visualize it that here there is a structural wall, load bearing wall, and on the top of that we have normal wall. Okay, so let's just deduct that much portion from this wall. And how to do that? I'll just go to floor plan, and herein I will just take this particular section here, and I would say that edit profile and go to section 2 and CC, sorry, CC, and yes, so it is hard to visualize, but I guess that here there is a puncture, so we need to create that from this to this. Okay, and delete and split 1 and 2. TR, join this to this, and it lost its connection over here. So this is one line, yeah. So join this to this, and this is joined. And so we just need to delete this particular line and just finish. And let's see it in 3D. Okay, so wow, perfect. Okay, no issues. And I suppose that there will be a beam here and also there will be one wall here. Okay, so let's just do that. So let me just go to ceiling plan of plinth level and beam. And with this justification top, that's fine. Just snap from this point to this point. Okay, and just move it. Okay, and let's just see it in 3D. Yeah, properly. Okay, and also we need to snap the beam wall onto that. So where is that beam wall? Beam wall, and is this? No, this is beam wall 2, and just pick. Okay, and yeah, and just click space and then modify and join structural framing. Join the structural framing with the wall. Okay, and it's not properly snapped, so I guess we need to position it properly. 0.5 of an inch. Yes, and join this to this. Okay, but why is it? And just and disallow join. Okay, and perfect, and no issues. And this wall. Okay, yeah. So let's see it in 3D. Yeah, perfect. Okay. Only thing is that we need to join it again. So tab until it reads structural framing. Yes, and okay. Okay. And let's go to plinth level and construct this wall. HR and wireframe. Fine. WA, and let's select that internal wall. Where is it? Internal wall 4.5 and 0 and up to first floor. That's fine. Okay. Press tab and connect. Okay, and one more wall over here, but that would be unconnected and height of just 4 feet. Core face exterior. Yes, I guess that, yeah. So just move it and move it 0.5 an inch and yeah, okay. 3D and yes, okay. And before proceeding further, I would just like to view that particular house. Are we going correct? And as per the image, if you see that this front two walls are the brick walls with the cladding or exposed brick, whatever, it has this ventilation. And this wall, this courtyard wall with the brick jali is of this particular color, blue color or something like that. So let's just do the required changes in order to match. Okay. And for that, what I'm going to do is that I'm just going to select this main wall to and edit type, edit, and just change this wall and paint, wall paint. And I'm just going to duplicate this material and call it courtyard wall paint. And just copy and under appearance duplicate it as well and paste. And this is going to be RGB 50, 20, 100. Yes, and that would exactly look like. And the same want to copy and apply it here as well. And apply here as well. And okay, and apply and okay. Yeah, so that looks better. Fine. And also this compound wall, I'm not happy with the material. Let's change it to a retaining wall. Application of material is not important, but it should look perfect. Yeah, fine. Okay, and now that load-bearing exposed brick material should be applied to this walls. So select this particular wall and SA, that will select all these walls. Just deselect the rest of the walls. And with that wall selected, just go to edit type and edit. And actually this, in order to give this a different material, we need to duplicate this and let's call it main wall 3. Yeah, fine. Doesn't matter. And just apply it, load bearing wall, exposed brick. Okay. And copy and paste and paste. And here, no. So here that should go same wall paint in order to see that cut pattern with this graphics. Yeah, see. Okay and okay. Apply and okay. Perfect. And here too, I guess that this should change to wall paint. Yes, and okay, okay, fine, and okay. It's fine. Okay, does it resembles? Still, this color is not perfect. So I guess that pick 73, 93, 118. Yeah, this is that color. 32, 69, 128, 25, 62, 123. 22, 65, and 123. Yes. Oh, yeah. See, this is that color. Okay. Apply and okay. Fine. It should look perfect. That is the only concept. Okay. And now it is perfectly resembles this image. Okay. And again, this wall is the normal wall, main wall, and that shouldn't be changed. And here, this is the beam wall, which should be applied that material. And this thick beam doesn't exist anywhere, so we can just change the material. Okay. And copy and paste. Okay. Apply and okay. Fine. Perfect. This columns 1, 2, and 3. But have we applied that column somewhere? Uh, Load bearing wall and apply and okay. Yes. Okay. So now it exactly perfectly resembles the image and fine. Now we should proceed ahead with the modeling part. Okay. But before proceeding further, I would just like to cross check at various junctions the joint condition, whether it's perfect or not. So we'll start with this horizontal ones and flip the direction and keep this view range. Okay, and HL. Yeah, so see, and this to this, and join and switch order. And okay, then actually this is not joined. Yes, and then join and switch order. Also join and switch order the material part. Yes, perfect. Okay, this is very important. Otherwise, modeling can be done very easily in Google SketchUp also. But if you are using Revit, then we should make sure that each of the junction is properly rectified or not. Join and switch order, and yes, join and switch order. Perfect. And switch order again. Last but not least, yes. Okay, and here I guess there is also we need to see structural framing. Watch this point. Structural framing with the ball. Yes. Fine. So now your section is perfect with perfect joint condition and perfect everything. Just, yeah. Okay. The view scale is, I guess, the problem. Okay, let's proceed further. 1.8. Yeah. And this is the AutoCAD line, I guess. The AutoCAD floor plan showing. Otherwise, it's perfect. Okay, and we'll go to plinth level again and just shift this here. Just turn on the thin lines and scale to be something like 1/4 of an inch. Yeah, that's fine. Yes, so see, switch order, join and escape, HL and join this to this, switch order. Okay, and here it is perfect. Yes, so plinth level again and just this is wall within a wall or what? From where did we take this particular section and what is it cut? How we are cutting through a column. Okay. So we need to join that particular thing or column also. And that seems to be not joined actually. HH. No, that is joined. So why is it appearing like that? Okay, it is behind. Join and undo. Sorry. Plinth level. Yeah, okay. It is perfect. Yes, so this section is also clear. Just take here. And this, I guess, everything we joined perfectly without before proceeding further. Before proceeding ahead, we did it. So go back to plinth level and now the vertical ones. We'll start from this this point and I don't want to see unnecessary elements. Yes, everything is perfect. Join and this to this and switch order. Okay, and join. Here there is a corner beam with that. Okay, fine. Not 3D. Length. Just take it here somewhere. Okay, that's clear. And here, and it's perfect. Okay, this is remain. But is it getting cut? Yes. What is this? Oh, there's a load bearing wall. So yes, we need to join that as well. Yes, and join this to this and join and switch order. Yes, join and switch order. Yes, so why is this layer? Okay, let's move ahead. That's not much important. Let's change this load bearing wall material to have a cut profile, cut pattern of foreground with something looks like a stone. And it's not there here. Let's let's give it any. Let's give it this. Let's differentiate it. Okay, and apply and okay, okay and okay. Yeah, fine. So okay, and where we were in Plinth, take this section here and down on thin lines, join this to this, this to this, and this to this, and switch order. Why is this small piece of this layer getting inserted in this wall? This should not. Anyways, we'll figure it out later. Right now, we need to continue with the modeling part. Switch order. Okay, yes, everything is perfect. Yes, and the last. Okay, that's perfect. Okay, fine. So the modeling of this much is absolutely perfect as far as the joint condition and material, everything resembles which that reference image that is provided by the firm. Okay, and now we need to proceed further modeling of this particular upper floor. Fine. So first is that we need to lay the slab. So I'll just go to first floor, just close this unnecessary views, and let me just go to first floor, and we cannot see anything. That's fine. You can just change the, oh, we open the ceiling plan, not ceiling plan, first floor, and yeah, okay. So this, we have this AutoCAD plan. Let me just change this range to none. Oh, but everything will disappear. So let's say that Plinth first floor. Okay. And we need to construct the slab here first. Okay. So it's having some, so architecture and roof by footprints and with overhang of 2 feet. I would just like to draw a flat slab over here, offset of 2 feet. And this I will just bring it here. Okay. And I'll just select all of this and say uncheck define slope since we don't want a flat roof. Okay. And that would have the same material, 6 inch and wall paint. Okay. Apply and okay. And that's fine. And one more thing, sorry. Again, go to edit type. And since this particular floor plate will be resting on that, this will be first floor and it will be exposed. And yes, one more thing I forgot. Just go to edit type. And since this particular floor plate will be resting and will be exposed to the atmosphere and be affected by the rainfall, so we need to add layer of brick bed for waterproofing. So 1 4 and 1 4, and this would be BBC, that is brick beds. Okay, and that would be 100 mm, 4 inch, and this would be the finished layer, copy and paste, and that would just be a small sliver, 10 mm, doesn't matter. Okay, and apply and okay. Fine. And let's just go to 3D and see now. Yes, so now it's perfect. Okay. Now what we need to do is that we need to lay the floor plate for first floor. Okay. And in this particular first floor, we need to insert and load the AutoCAD plan. So import CAD, and yes, this will navigate to that particular location and first floor plan. And yes, everything is perfect. Manual center and inch and open and just paste it and just turn it to halftone, import categories and apply and okay, fine. And you need to snap it perfectly. So modify and let's find for some base point or common point. So this is that point. Okay, so just align this to, no, but again, this wall will be having the plaster layer, so we need to snap to wireframe, and yes, LI, and this is the point where you're supposed to snap. Okay, and align this to this, and this point. Uh-oh, it left the connection. Actually, let me just let just click undo and draw a line, and draw a line here as well, or actually move this point directly on that point, so that will snap perfectly. Okay, so now the floor plan has been properly pasted. Okay, and it's perfectly placed. So now we just don't need to see what is happening below. So I'll just change this range level underlay to none. Okay, fine, and we can visualize our plan properly. Yes, so it's perfect. Okay, so now we need to lay this particular floor plate and go to architecture and floor architecture, and where is the Plinth floor PCC? Okay, I'll just edit that and duplicate it and call it first floor passage. Okay, and edit, and now this would be a slab casted since it is on the first floor. So just change this to concrete, and cast in place gray, which has that cut pattern of concrete. Yeah, fine, okay. And that would be 6 inches. And here you need to insert a layer of PCC, and that would be finish 1-4. And this would be sand bedding or PCC, sand bedding or PCC. Yeah, that's fine. Okay. And that would be just 20 mm. That's enough. Okay. And we just need to change this particular material, the tiling material, to first floor balcony pathway. Yeah, that's okay. Or you can just apply this also. That's not a problem. And okay. And apply and okay. Fine. And with that, I'll just draw this line, and from here till this point. Okay. And actually, this point will connect here, and this point will connect here, because the TR and TR, and join this to this. Oh, yes, one more line. Split, and join this to this and this to this. Okay. And just finish. Don't attach. Yeah, let's just see it in 3D. Yes, fine. Okay, and that particular floor plate is perfectly laid. What just we need to do is that first floor, and watch it in section, and we need to elevate it, and how much that is. Oh, UN, and just turn this to millimeters, 0 decimal places. That's fine. And what are the finishing layers? 51. Yeah. So 51 mm. We need to give it a height offset 51 mm. That's fine. Okay, perfect. And just join it. So join with this, and also join with this structural framing. Watch this point. Framing to floor. And yeah. Okay. And also this will have a layer on this end in order to hide the structure part. So down, and that would be finish 2 5, and that could be same, copy and paste. Okay, that could be just 12 mm. That's enough. Okay, and up to the end. Okay, fine, and just join it, this to this and this to this. But just we need to switch order, Yes. And yes. Okay. Perfect joint condition and perfect 3D. Yes. Okay. Now, what we need to do next is that first we need to construct this particular staircase going from this level up till this here. So as far as AutoCAD plan is concerned, uh, forget about the AutoCAD plan. Let me just flip this section and let's just see that what is the level that we need to reach. So we can manipulate the staircase that way. Fine. So just measure it from here till the finished floor. Okay. The 3251 is the height. Okay. That's not exactly 3 meter, but due to the finished floor levels and due to this drop, it is 3251. So we need to manipulate our staircase in such a way that will be laid perfectly. So if you divide, if I guess that how many risers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. 20 risers. So if I just say that 3251 divided by 20, so one riser is 162.3251 divided by 20 risers. So one riser will 162.55. Okay. So we need to model it that way. So I'll just delete this and I'll go again go to first floor. Yes, okay. Not first floor. Yeah, we can lay it here also, but architecture and stairs and does that allow? Yes, the base level should be, yeah. Let's say that the base level should be plinth level and the top level should be first floor. Okay. And with that, I would say that 20 number of risers. Okay. But actual tread depth should be 12. 12, so there's 12 inch. Okay. This is 12, I guess. Yes, 304.812. Yeah, fine. And how to manipulate the risers. So we'll do that. Just let me just first edit type and duplicate this and call it custom. Okay, so we don't end up messing with the system and just say this to none for now. Everything to none. And yes, thread thickness, everything is fine. Yes, okay. Let me just click OK and run. And from here in, I'll start. And let's just complete. Desired number of risers should be 20. Okay. So with that, I would say that run center, not run center, but run left. And with that, what is the tread depth? This is 1 to 4 feet. Okay. So we also need to change that. So run, and this should be 4 feet run width. Yes. So 1, 2. And with that, if I just run that, again, this has changed or what? Actual thread depth 12 inch. Yeah. So these are instance properties. So every time you change any variable, this properties will change. And with this now, I guess that it's running perfectly and 20 risers created and 0 remaining. Okay. Okay, fine. So let's just finish this. Now, what we need to do is that uh, the stair riser height, the actual riser height, we need to change. And where is that edit? And under this, I guess riser thickness is 6.4. No, what we need to do is that for plinth level, we'll have a base offset of 6 inch. See, because in section, if you just see that this particular staircase is starting from exactly from plinth level, but we need to give it a base offset in order to make it reach that particular sim. So base offset of, let's say, 6 inch. Okay. Or not 6 inch, -6, -6 inches. Yeah, fine. Perfect. And with that, yeah. So see, it is absolutely perfect and with no issues. Just say that select this tab and uncheck end with riser. Okay. Now, as per the AutoCAD drawing, whenever the person will step from the passage, the ground floor passage, he will directly step on the first step. Okay. So we need to manipulate it that way. So in order, we edit steps and this and convert it to sketch base. Okay. With that, just edit sketch and the first step should be here. Fine. And with that, TR and join this to this and join this to this. And the stair path should, okay. And one remaining, it says, doesn't matter. Move this all the way here. And the last step also, you will edit. Okay. And with that, TR and join this to this. Okay. And this is perfect, I guess. So just finish. Invalid sketch. Why? Continue. And oh, we need to join this. Oh, sorry. We need to join this and then finish. And now if I just take the section finish and see it in section, then you see that this is your steps perfectly. And you see that modify. And if you measure this, then the last step will be exactly, see, perfect. And if you just flip the section, then you'll be able to, and if I just click this, then you see that, let's just measure this. It's reading 211 and here it is reading 160. So we calculated this height. We calculated this particular height to be 3251 and that I guess should read perfect. Oh no, from this bottom, I guess. Yeah. From here till here. Yeah, so 3251 and divided by 20. So that should be 160 point something. Okay, so I will just select this and see, just like we gave a base offset of 6 inch. So again, your first floor, the top level of first floor, there should have a top offset of 51 mm. That is the finished flooring. Okay, and with that, the desired number of risers should be 20. Okay, and yes, and now if you measure, then all your risers will be of same height, and that would be that same variable which we calculated 162.6. See here also. Okay, and that is perfect. If let's go to 3D, then that particular stairs have been perfectly created. Only thing that you need to host the railing onto that architecture. And why did it delete the railing? I don't know. Somehow I must have unchecked that function. So otherwise, it would have created the railing and create railing and place on stair ramp. And I would just select this particular. It's not allowing to. Why is it not allowing? Assemble staircase custom and yeah, this is the railing. Uh-oh. HR and yeah, so see, I told you that it might be, but this since because of this custom sketch, this particular glass panel bottom fill is not referencing properly. So what we just need to do is that we need to change it to handrail rectangular or some another guardrail pipe. Yeah, that's fine. But we need to edit the sketch wherein this is from here the person is going to step onto this courtyard. Okay, so edit path and onto plan first floor. I'll just change this from here to here and just finish. And let's go to 3D. Yeah, fine, perfect. No issues. And let's just now try hosting that glass panel bottom fill. If it works, yes, it perfectly works. Okay, that look good. CC. And yeah, see this unequal distribution of this panel and it's creating a problem. So let's just change this to guardrail pipe. Yeah, okay. Fine. And with this, as per your design, you can add this supports. And well, again, I'm just going to say that the middle support, and I want three of them. Apply and OK. Those are the stringer beams. OK. And if you just HI, and you see that your staircase has been made with that particular stringer beam. OK. Going from this to going from the plinth level up to this first floor designated level. Okay. Fine. R enter. Perfect. And if you want, you can change the materials of stairs also. Edit and where are the materials? Yeah, tread material and riser material. I'm just going to stair. Have I defined a material? Yes, stair material is there. Okay. And copy and paste. Apply and okay. Apply and okay. That's fine. What I am not happy with this particular flooring, I want a different flooring for this. I mean, different material for this first floor fabric. And let us just change to something else. Yeah, okay, let's change this. Okay, and apply and okay. Just to distinguish a bit. Okay. And I guess that, yeah, fine. Okay, no issues. Okay, so now what next is that we will add the openings later. First, once we are completely done with the modeling part. Okay, so we need to construct the floor plates of the rest of the parts. Okay, so which is going to be this is going to be the terrace and floor architecture and edit type and duplicate and call it terrace slab. Okay, and everything will remain the same. Only since it will be affected by external rainfall, you need to lay the flooring, the layer of brick beds. Okay, brick beds, and that would be 100 mm. Okay, and the finished floor material should be terrace. There is nothing. We have to again select something else for this. Tiles and tiles. If I just see that first floor pathway, roof tiles, yeah, we can add this roof tiles. Okay, that's okay. Fine. And okay, and this can remain the same. Okay, everything is perfect. And okay, apply and okay. And we will just a clear cut rectangle. Okay, and just finish. Don't attach. Yes, and now this bedroom. Bedroom. So again, floor and floor architecture and edit type and duplicate this and call it, or let me just select first plinth floor, first floor passage, yeah, because the same layer will persist. First layer, first floor passage, yeah, and edit type and duplicate and call it first floor private. Okay, and just go to edit type and just change this to first floor private. Yes, okay, and rest everything will remain the same. Yes, and this will not have a layer of brick beds. Okay, apply and just draw the boundary of that. And this will connect from here to here and from here to here. Yeah, that's fine. And okay, and don't attach. Okay, both of these floorings we need to properly align it. But before that, let me just create this washroom. So washroom slab. Okay, And again, once again, floor and floor architecture. And this time, the wash tiles, the floor plates, the that we selected for the ground floor, we'll just duplicate it and add the layer of brick beds to it. Since on the ground level we didn't add the brick beds since it is resting on ground, so there's no need to add waterproofing, but this will have. So where is that? First floor and ground floor. Why couldn't I find? Come on. Okay, just discard it and let me just go to plinth level. What was the name of this flooring? HH and washroom floor plates. So come back to first floor and floor architecture and washroom floor plate. Where is that? Yes, here it is. And edit type and fine and edit. And this will have the same finishing mosaic tiles. Okay, but the layers here will be different. Okay, wherein this would be a thick RCC slab casted. So concrete and concrete cast in place gray. Yeah, that's fine. And herein we will add two more layers, both of them 1 4 and copy 1 4. Okay. And here too we'll add one more layer and that would be finished to 5. And this small sliver is enough, 12 mm. Fine. And that would be the same first floor public. Yeah, that's fine. Yes, this is the material that we assigned. Okay. And yeah, so this is going to be from bottom. What you are going to see this same material. I mean, you can keep something that looks good also, but that's fine. Okay, no, let's not waste time on that. And let's just remove this mortar. No, before this, yeah, this is going to be down. This to be down as well. And yes, right now let's provide 100 mm BBC. But there is a special way how to align that particular floor plate, that slab that we are going to cast. And I'll just show you in section. But right now I'm just conventional and this will be send bidding or PCC. Okay, and that will be 20 mm. Yes, that's fine. Okay, and with that, now I'll just press OK, apply and OK. And I'll just create that rectangle from here to here. That's fine. And just finished. Don't attach, highlighted floor overlaps. Which floor overlaps? This, neither this. This overlaps. Okay, so edit boundary. Just take this inside. No, but here we need that particular thing. So let's just draft it. 1, 2, and TR and join this to this and join this to this. Join this to this. Okay, and finish. Don't attach. And likewise, also you need here. So 1 to 2 and 1 to 2. TR and join geometries and have a close shape and just finish and don't attach. Yeah, okay. Now let's just go to 3D. Fine. So now we need to properly position this in place, all this particular flooring. And yes, see, for this particular one floor plate, I forgot. Let me just select this and edit boundary and again go to first floor. And yes, here too we will have that. Okay, and just finish and don't attach. Yeah. So now how to position this properly, how to lay this properly. So in order to lay this properly, we need to go to the section of this. Okay. And then we will join in section all the geometries after taking it to designated level. So first floor, and I just take this particular section all the way till here. Fine. And we can very beautifully visualize there. Fine. So no issues. And first is this terrace level. Okay. So what needs to be done? Measure this unfinished level 151. So just give it a height offset of 151 mm. Fine. So this slab joins with this particular beam. That's perfect. And now the join condition and modify and join. So join first. This is very, very tricky, and I don't think that we will get it at first go, but let's just try. Join this to this and switch order this to this. Oh my God, we got it perfect. No issues. And just like that, join this to this column and this plaster to this finished layer and switch order, beam and floor. Perfect. Now, important is that what should be the height of this BBC in order to have this one tile drop. Okay. So you need to sit with the calculator wherein you just need to measure that if this is 151 is the height of that particular flooring, and in order to have this one tile of drop, you approximately need this brickbat layer to be as from previous sessions. I just remember it. You sit with a calculator and manipulate it, but I guess that 280 mm will do the job. Apply and OK. And with that, if I just align from this to this, yeah, so we perfectly have, but I guess that, oh, what, what it did, washroom floor plate. Oh, yeah, sorry. So this might have changed here as well. Oh, here we don't need actually, but that's fine. If it's created, then let it be just like that. I forgot to duplicate it. So that's why. So this should be edit and duplicate and call it washroom floor plate 2. Okay. And just apply. And for this particular floor plate, let's just change it to what it was, wherein this was the PCC layer, copy and paste. Okay. And we didn't have this particular brick beds, and neither we had the sand bedding, and we simply had this. This was the anatomy of that floor. Yeah, fine. So it's perfect now. And join again in order to have the perfect connection. Yeah, okay. So this is the floor plate for washroom on ground floor, and there we don't need waterproofing since it is already laying on ground. But here we need it, and I just forgot to duplicate it. Okay. So if I just change this particular brick beds layer to 280, and with that, if I just try to align it with and align this part. Let me again change it back to 100 and OK and apply and OK. Fine. So this particular beam should be here, should be flushed here. So if I just move it at beam bottom, yes, highlight it to overlaps, that's fine. Yes. No, okay, fine. So at beam bottom, this slab will be at beam bottom, and now we will add this particular thing and give it a 280. Okay, apply and okay. And then just flush this, align and this to align tab washroom floor plate. But yeah, we need to align it here. This to this. Oh, perfect. Okay, and you see that we still need, in order to have one tile drop with this finish, this layers, this flooring. No, but we need to consider this flooring because we are going to step it from here. So I will just take, we will decide in this section that what should be the, yes, and this is the front part roof floor plate. Section 1, yes, and yes, okay. So this is the washroom floor plate, and yeah, it is exactly having one tile of difference. See, I told you that from last sessions. I already know I have calculated it and manipulated it, so I know that with 280 will do the job. Okay, but what we need to do is that this walls will stop here, this particular internal wall, and herein we need to have a perfect join condition. And for that, what we need to do is that edit type and first join it, and then after joining it, we need to lay that. Otherwise, it will not join perfectly. So join this to this and switch order. Yes, and perfect. And join this to this as well. And yeah, fine. So now with the perfect join condition, and now with this, after joining, what you can do is that you can again switch back to what it was. Apply and OK, and just align it with this to this. And yes, we have a perfect join condition. Only thing that we will need a beam over here. But right now, I'll just ignore that part. Okay, we will need a beam over here. If you just see this particular thing from bottom, then what you notice is that, oh, but we cannot see it. Huh. How to see that? H, yeah. So yes, so here we need a beam. Okay, so that's fine. Okay, HR. And yes, this flooring is pretty much high because of the brickbat layer, and this should actually be go down with respect to this flooring. Otherwise, all the water will. So again, let's go to section 2, and this is that floor plate, and let's just move it, move it to this point. Yes, or instead, this floor plate, let's just connect it to the beam bottom. Let's flush it at beam bottom, and this should connect to this. Okay, fine. And then just raise the layer of BBC a little bit. Again, 280, same. It will exactly have the same formation just like this. You can manipulate it according to your design, but I'm just making you making your concept clear. Okay. Now again, we need to join this. So we first need to go to edit type and make this 100. Okay, apply and okay, and move from this point to this point, and then first join it. So join the structure with the beam with the floor plate, yes, and then join and switch order this to this. Now this is going to create a problem. Join CCR enter HL. Join this to this. Switch order. Oh, perfect. But again, here there is a beam, so switch order and this Um, let's press undo. See, this is time consuming, but if you want to do things with perfection, then otherwise there is no point. Okay. So let's just unjoin it, undo, and yeah, everything is fine. Okay. And to first join this, select this beam, floor, and switch order, beam and floor. Yeah, fine. So there's just the hierarchy of steps which we need to follow. Okay. And just like that, join this beam with this floor and then switch order this to this and perfect and join this as well. Okay, perfect. And with this, now you can just go to edit type, edit, and again say that 280. Okay, and apply and okay. And just align it this point to this point. And yes, perfect. Okay. So now if I just go to 3D, then everything is in place and we have a one tile drop, just like this bathroom, this washroom. So that will not, okay. And here is that something we need to join this particular flooring, CCR enter, and join, and just I'm not able to visualize. Let's just try to H hide AutoCAD plan and join tab structural framing with this. Or let's see it in section floor plate and yes, see that section. And what is the issue? This is the washroom floor plate, yeah. And this is the topmost CC R enter section 2. Yeah, okay. Join and join this to this and join and switch order. No, it's not yet joined. Join beam to this and yes, switch order and yes, okay. But this finished layer should, there is the problem. Mushroom floor plate. I guess that this particular flooring has not been laid with this 51 offset. Yeah, see, so that's why we need to. Okay, okay, okay. Sorry. Fine. So now if you just see this in particular section, then that will perfectly flushed. Okay. So this is how you work with perfection in Revit regarding the joint conditions and everything. Okay. Now we need to draw the walls over here. This bedroom wall, first floor, and quickly I will just, we have a store also here, but that's not, so just WA and with that main 9-inch main wall from first floor to base offset 0 and core face exterior and top constraint to, oh, we don't have the level defined, terrace level. Let's just go to south and define one more level, LL, LL, and the offset of 10 foot. Yes, okay. And that would be terrace level, terrace level or slab top, whatever you say, because anyway we are going to design that sloping roof, so it is not important that what you name it, but just that for, we need to draw the walls. So that walls should snap to some level. So that's why that level is needed. So WA and main wall from first floor to terrace level, and with core face exterior, just snap to just select this point, and those will be the regular walls. So where to construct it from? Yes, let's flip the direction and start constructing from here. And one, and press tab and connect it. Yes, and also here. Okay, and we'll come to this point. Yes, and TR, and join this to this, and join this to this. Okay, and also we will have one wall here. Okay, and this wall will edit profile and go to section 2, and we'll have opening, so much of opening, that is but right, not able to visualize because of no reference. Let's go to 3D. Okay, and here there will be a puncher with beam bottom. Okay, but I guess that I forgot this particular this wall, and also one thing we forgot. I'll just bring to your notice. I'll just go to first floor and first construct this wall WA, and that is going to be the internal wall. So internal wall 4.5 and first floor and terrace level. Yeah, that's fine. And finish core face exterior and just draw this to connect this to this. Okay, now what important thing we forgot was that we constructed this wall, but we forgot to take the structure. I forgot to elevate the structure. Okay, so what I'm going to do is that I'm just going to hide this walls. Okay, for now, and those are going to be what we will do is that we'll select this entire chunk, and I'll say that filter. And actually, if we are going to do it that way, then let's select this and filter and check none and just structural columns and structural framing. Okay, and apply and okay. And with that, I'm just going to isolate category. Fine. So now this is a little bit difficult to visualize, but that is how it is, and we have to fix it. Okay. So what I'm going to do is that first is that we are going to suppose we are going to take this particular this so many columns and just select this and filter and check none and just select the structural columns, apply and okay. So with this column selected, just deselect this because that will not go above, and also not this one. Only this six columns will go. And for that, for those six columns, what I'm going to do is that I'm just going to change this top constraint to terrace level. Okay. And likewise, we need to select the beams and the structural framing. Okay. We also need to take the structural framing above. So just select this and this two beams. Okay. And just deselect all this. Okay. By cross window. Fine. And this just copy to clipboard and paste align to selected levels and take it up to terrace level. Fine. Oh, perfect. Okay. So see, this is the one was selected, which was not actually supposed to be taken up. So this is, and just undo it and just select this structural framing and select this and this. Okay. With only this much selected, just copy to clipboard and paste align to selected level and go to terrace level. That will, oh, we made a wrong selection, so that's why. It is very important that what elements you select. So just select all of this and again select this beams and cross window and deselect all of this. Oh, deselect, I said. Fine. So nothing else is selected except this beams. And with that, now copy to clipboard and paste align to selected levels and up to terrace level. And that will do the job. Okay, fine. So that is how you work in Revit. Okay. Now, what is next is that first we need to join the geometries. So modify and first let's go to plan and join the geometries there. Turn it to fine and hide the AutoCAD plan, H, and yes, so join and select this column and this wall and column and this wall and column and this wall and turn it to hidden line. Yeah, fine. So again, join and select the structural column. Watch this point. It should read structural column and join this to this and multiple join. With multiple join checked on, select this and this. Okay, done. Just like that, join and 1 and 2. Great. Join 1 and 2. Okay. And we don't have columns on this face because this particular wall is resting already on the structural wall. Okay, so now we have something for reference. Okay, only thing that we need to add the structural columns to this, but herein we will just take that particular column above, but here we will add. So add and column architecture, and we already have that rectangular column. Just say that height up till terrace level, and why is that we cannot see it? Oh, HR and column again and column architecture, and with that selected height up to terrace level. And why is that we cannot see it? Okay, yes, it's place and just rotate it and go to the this dimension and then just modify and align this to this and align this to this. Okay, and just change this to hidden line and this thing to wireframe. Yes, okay. And just join the structural column with the newly created this HL and yeah, fine. And herein, what you will do is that you just go to 3D and select this column and just take it to the floor level above. Fine. And just join and select that. Press tab structural column with this and likewise also the beam with this. Okay, CCR enter, join and beam with this. Yes, okay, and R enter. Yeah, perfect. Okay, so see, no issues. Absolutely perfect. Okay, now what we just need is that, yes, join. We joined in plan, but we also need to join it here. So structural column and wall and structural framing and wall, structural framing. Oh, sorry, too fast. Sorry. Uncheck multiple join and wall, framing with the wall, framing with the wall. Yes, that's fine. And likewise here too, uh, wall with this and this. Yes, okay, perfect. Now we have something to reference to, so we can just deduct this particular fine and we'll just do that in a minute. But before that, I want to add the beam wall over here. So WA and let me just select this beam wall which UN and just change this to feet and fractional inches, nearing us to 1/4 of an inch. Fine, okay. And WA and beam wall, and this is not that wall. So select this beam wall too. Yes, so 10 inch. Fine, perfect. Okay, and just snap. and select this and highlighted walls overlap. Mm, yes, sorry, wrong constraint. So WA and beam wall that should go from first floor 8 foot, 5.5 inch, and up to terrace level. So that unconnected will be 1 foot 6.5. And just pick and it's hosting perfect. Core face exterior and highlighted walls overlap. Yeah, but we'll just bring it. Select this as well. Yes, fine. Okay. And just go to first floor, or let's say the ceiling plan of first floor. You'll be able to visualize that and just flip it and bring this all the way to this point. And likewise flip it and just bring it all the way to this point. Uh-oh. Connect and yes, connect. Okay. Okay. And 3D. And this should be taken till that, but we don't have anything to reference to. So again, we will go to 3D, 3D back. Yes. And herein, I would just select this point. Yes, but the point is fine. We will just continue it once we draw this particular once we elevate that particular load bearing wall above. But first is that join and join this to this. Okay, fine. It's joined and it's perfect. Only thing is that here there is so join and join. Yes, perfect. Okay, now we can create this puncture while going to the floor plan, first floor plan, and just take this here. And with this, I suppose that we should be able to visualize ZA and just take this section. Uh-oh, I'm not able to visualize anything. Yes, because of the view range. And just change this and CC. Okay, and just edit this profile and HL. So fine. So no issues and L line and you need to create this line, this point, and also actually we we can select this entire chunk which we want to deduct. And why is it snapping to the yes, snap to this face and this point and just finish. Wow, so we have created that puncture, okay, which will be the go through. Okay. Only thing is that here there is some error again. So let's go to section 2 and edit profile. Mm, what is it? Just finish. Yeah, it's so we need to check this section in order to properly join it. Yeah, see, this is the error. So join and join this to this. Yes, perfect. And also join this to this. And yes, and just join and switch order. This should not have gone inside. Yes, this beam is already, then why? Okay, little bit of glitch. That's okay. That's fine. Mm, join and switch order. Yes. And then join and join this. CCR enter and HL and find and join. Oh, okay, this is better condition. Okay, that's fine. So just ignore few Yes. And I guess suppose that join and this to this. Yeah, fine, perfect. Okay, no issues. So you see that as per the image, this particular wall is resting on that particular load-bearing structural wall. Fine. Now we need to elevate this particular wall, but for that I just need to show you this image. And you see that this particular wall is stopping here. And then we have the brick cladding, which is hosting the slope roof. Let's see some another image of that in order to properly understand this. So see, this particular wall stops at this point, and I guess there is an image which shows its exact location. Yes, and yeah, so see, at this particular staircase, this wall will stop. Okay, so we need to again elevate that wall differently from that level. So I'll just go to first floor and herein from here till this point. So WA, and where is that structural wall? Load bearing stone wall? Yeah, fine. And I'll just change this to 0. And we will start from this point and we will end it over here. Okay, that's perfect. Okay. And with this, now if I just go to ceiling plan of first floor, what we can do is that we can extend this to this point and extend this to this point. What is the issue? Unjoin? Yeah, that's fine. And let's go to 3D. Yes, perfect. Okay, no issues. See, done. And now we will have a different profile for this, but that the sloping roof will decide what will be the profile. Fine. And what else? Yeah, fine. So now what we just need to do is that construct that particular sloping roof. But before that, I would just bring life to this particular project by adding openings to it. Okay, yeah, and we need a parapet wall over here. So let's just do that quickly. That is not a big deal. So WA and main wall, 9 inch and first floor and unconnected height up till 3 foot, 900 mm, 90 centimeters, zero point 0.9 meters, and we will just add that. And why is it not snapping? W wireframe, and yes, start from this point, press tab. Yes, and this to this, and this to this. And here again, what will be the scene is that we will have a regular wall, but that will join with the roof in a such a way. I'll just show you. So let's just construct that same wall, WA, from here till here as well. And just go to 3D. And yes, it's perfect. Perfect. Okay, with this particular niche. And yeah. So now we are getting closer to the reference images and we are almost done. What we just need to do is that add a sloping roof. But before that, I would like to bring life to this particular, I want to bring life to this particular project by adding the openings and ventilation. Fine. And also, if you just see this particular image, then herein, this is the ventilation which is added here. So, okay. But we have taken the consideration, if I just talk about this structure, then you see that in this part, in this particular height, up till this height, there are no concrete beams. This is the metal beams, the fabrication, I section, I channel or C channel, and then the cladding has been done to it or colored it. Okay. And the same applies to this roof also. It's not a concrete roof. This is metal deck. Okay. And so they don't have any beams over here running along this periphery. And I suppose that this is the load bearing wall as well. Okay. But we have taken the consideration wherein we are considering this as a frame structure okay, which has this beam column. Oh, it's got stuck. Let me just go to Revit and yeah, and let's go to ground floor. And if I just see to make you see this AutoCAD plan, then we are considering this to frame structure with beam columns, but images shows something different, wherein you see that this, so see this metal columns, and here we don't have any beam. Okay, but if we want to add ventilation, then we can do it here. Here is here itself also. And how we will do that? So I will just go to first is that I will just go to 3D and take this particular and give it a base offset of 18 inches since we're going to add ventilation of 18 inches. And that will unjoin. Yeah, that's fine. Okay. Okay. And next, what I'm going to do is that I'm going to first floor and herein I will define architecture and wall. Okay. And that should be the curtain wall. And I'll just edit it and duplicate it, calling it ventilation. Ventilation. Okay. And that should be automatically embed checked on. It doesn't matter because we anyway don't have any wall or anything there. Okay. And vertical and horizontal grid we will lay later. First is that I want to make that thing. Should start from here all the way to here. And this will, oh, sorry, we are adding on the wrong location. It should be actually here, but we are not able to see anything. So wireframe, or let's say that range level to plinth level. Yes, and with that we can see and walls and with the curtain wall ventilation, I will just snap it and create that one going around the periphery and okay, and let's just fine. Okay, and let's just see it in 3D. Yes, okay. So that is having a height, unconnected height as SA. I will just select all of them and give it a height of 18 inches. Fine. And you have your ventilation hosted on the top of structural elements. Fine. But we just wanted to match that image. So that's why I have provided this. And this will not be in continuous parts. We'll have HI. And let's me just select out of this SA and HI. And we'll have grid, curtain grid at few distance. Let me just divide this piece of glass because a glass doesn't comes, and this I'm just randomly dividing it. Yes, just to make it look visually appear perfect. One is too less, at least 4 feet. Yes, that's enough. And one over here. And just randomly adding. Okay, 3 foot. Yeah, fine. That's enough. Okay, and then what we'll do is that we'll host a mullions onto this and we'll select the smaller mullions, 1 inch square. And let's say all grid. Perfect. Yes. And what we'll do is that I'll select any one mullion and go to its edit type properties. And herein, instead of aluminum, I will enter the material sash. That would just look like a wooden member. Okay. And with this, I'll just press HR and that would look much better. Fine. The division of grid is not accurate, but that's fine. I just wanted to show you the concept of that. Okay. Now, what is next part? Yeah, adding openings and bringing life to this structure. So let me just close all of this and save it before I lose it. And select both of this AutoCAD plan and hide in view by category. And here too, hide in view by category. That's fine. Okay. And now let's me just go to the plinth level and let's start adding openings to this. Okay. And if I just HL and fine, view scale is too high. Okay. And let me just see the AutoCAD plan. And you see that here we have a couple of windows. Or let's me just turn to wireframe so you can visualize. Okay. Modify and just measure this. So this is 6 foot. Okay. So I will just say that DR shortcut for door. And here we have lots of doors, which I have loaded also, my custom door. And on that, I will just select this. Okay. And try to host that. Okay. Fine. And that's okay. Let's just check the all of this to Shash and select, copy and paste. Oh, well, this is going to take a bit of time. Okay, and paste, paste, and paste. Okay, fine. And let's go to the type properties and let's check that what is the overall height. Width is okay, that's fine. We can adjust the width according to the AutoCAD plan. But what important to is that it shouldn't exceed the height, overall height. And the total height is 7 foot. Now let's just change it to 8 foot. That would be lintel, 8 foot 6 inches. Oh no, 8 foot 6 inches. No, 8 foot. Let's keep the lintel to 8 foot. Apply and okay, fine. And since this is the parametric family, so it will take a bit of time to regenerate. It has a lot of parameters assigned to it with the parametric door. Okay, and here there are two windows, fixed windows. So again, WN and just select this fixed window, 36 by 48. And how much is this? This seems to be 4 feet. And let's just host it here, 3 foot. And this to here. But this is the bigger window. I guess, yeah, let's just add. Then we will just measure this and 4 feet 11, that's 5 feet. So just edit type and duplicate it and call this height to be width to be 5 feet and its own height to be, if still height is 3 feet, then its own height in order to make the lintel 8 foot. I'll just keep it enter 5 feet and just apply and okay. That's fine. And here this too needs to be, this is 4 feet and the height in order to make match the lintel. There is just one parameter which we just need to. Okay, fine. And here there are two. Here there is a door. So DR, and let me just select this interior and just host it. Press space and host it onto this wall, and single flush 36 cross 84 or 36 cross 80, and just put it here. And here also there are big windows. Fine. And here there will be ventilation, but ventilation where we will add lures, where will we add lures from, and I suppose that I have added that. Oh no, it's not that. Oh yeah, that will be in window. Fine. So now I just click window WN, and it's parametric classical window. Just host it one over here and another over here. Fine. We'll just adjust it later. WN and simple simple sliding window. I guess that I have loaded that. Yes, sliding 4, and yes. So just edit it and duplicate and say that its width to be 10 foot and sliding height is 2 feet. How is that height is 2 feet only? Height should be 8 feet, 5 feet, I guess. Yes, apply and OK. Let's just load it here and let's just see it in 3D. Oh, wow. Perfect. Okay. And this too, I suppose that its sill height should be 6 inches. Yeah, fine. And this window, because it gives a classical Roman look, traditional architecture, since we are going to define a sloping roof and also this materials, exposed brick and the stone wall, so that just thought of hosting this particular window. Fine. So let's just move forward. And again, let's go to Plinth level. And here there are two openings, two sliding doors. So just, and let's see that whether we have sliding door. And have I loaded one? Yes, door double sliding. I'll just select this and host it. Okay. And size of this door is 10 foot. So let's just make it duplicate and okay. And just width should be 10 foot and height to be 8 foot. Okay. And just apply and okay. Yes, perfectly. And that CS, select that and CS, and that would create one more of that. And we could host that here. Yeah, fine. Okay. Just like that, onto this particular wall also, we will have sliding doors here too. Fine. And CS, let me just host one over here and one onto here, this face. Like, okay. And here we'll have the sliding folding door. So DER, and I have that family, parametric family sliding folding door. And let me just go, but it's too huge to occupy the space. Let's select type B. That would be still bigger, I guess. And it will take just some time to regenerate parametric family. And it has, no, yes, sorry. Yes, so type A is better. DR, and yeah, type A is fine. And we'll just host one here and here. But first, let me just edit type and decrease its overall width to 10 foot and apply and OK. Yeah, OK. And yeah, that's better. But I should have kept it 12 foot. Okay, 11 foot 6 inches. And with that, I suppose that this width should change to keyboard door width and height to 8 foot. This parametric windows width is this and sliding folding width is yeah, fine. Okay. Apply and okay. And I suppose it should occupy, it should properly be hosted. Yes, and just move it a bit. Yeah, fine. And just DM, that is okay. And I suppose that here there is a join problem. Let me just select this structural column and architectural. Yeah, fine. Okay. So that's fine. And let me just select this window and all this. Again, that is going to take a bit of time to regenerate. Paste and paste and paste. Okay. Material part. Yes. And let's just open up that door. So angle of rotation, I will just change this to 45. So that will open up that door, sliding folding. Yes, because it is a parametric panel. Yeah, so see, perfect. And this to 90 degree. So this shutter will open up. Fine. And in this case, I will say that this to be 45 and this to be 90. Wow. Okay. Perfect. Let's just see it in 3D. Okay. Great. Okay. And why has been this? Oh, yeah. We haven't changed the material for that. So it's appearing all white. So just change all this to sash, paste, paste, and paste. It also has the louvers, the horizontal and vertical louvers, this which you can open and shut. It's complete parametric. Fine. Okay. And what is the scene here? And here there's a sliding window which is perfectly opening up. Yeah, that's just select both of that, and we need to give a 51 mm of offset. Oh, sorry, 51 mm. That is the finished floor level. Yeah, fine. Okay. Yeah. So let's again go to plinth level and host the door and windows over here, and WN and doors 1624. I'll just edit type and just change it to width to 2 feet. Yeah. Apply and OK. You don't forget to duplicate. And the sill height would be 6 feet. And place one here. Will not be seen in plan. And one over here. Here there is a, so let's just place here. OK. And move move it from here to here. That's fine. OK. And here we will have a simple fixed window. Or let's say that this sliding folding double hung one and two. Okay, and the same will be here one and two. And since here there is a, so CS and yes, okay. And as for the image here, there is one door, steel door. So I will just select that particular door and host it. Yes, which can be used for access. Okay, and here there is a fixed window. So WN and window fix and just edit type and duplicate this and height of just 2 feet and default cell height to 6 feet and width to 10 feet. Okay, just apply and OK and place it here. That will be placed at its desired location, and let's just check. Okay, fine. So see, but its width is too much. I suppose that this width should be only 8 feet. Yeah, fine. Okay, and all this window, edit type and just change this to sash, apply and OK. And yes, the lures has also been added. And here is the window and OK, fine. So we are done. Okay. Now let's just go to first floor and quickly first is that we need to create railing over here, but HH and let me just change this underlay to none. Uh-oh, underlay to range level none. Okay, fine, and we can visualize this properly. And now I'll just say that architecture and railing, and I will just select this handrail rectangular, edit type and duplicate it. Okay, and therein I will say that rail structure, I don't want anything. The baluster placement, I will just drop this down to the domestic baluster that I have loaded. Okay, and copy and start post, paste, paste, and paste. Okay, and distance at distance of 18 inches is fine, and apply and OK, apply and OK, and then sketch path. So I'm just going to draw it from here till here. And first, let's see that how it is getting placed. Okay, move it. And I guess that we need to remove the start end corner and we'll say that none. Uh-oh, too fast. Sorry. Copy, paste, and paste. Okay, and apply and okay, and we'll just have the regular balusters at 8-inch distance, and that's fine enough, fair enough. Okay, and let's give it a base offset of again 51 mm. How much is the finished floor level? That's fine. Okay, and we'll just CO copy it from this point to this point and paste it here and here and just edit path. And here I will just take this all the way till here, edit path. This I will take it to here and edit path. This I will take to this point. Finish. That's fine. And let's just see it in 3D. Okay, perfect. So see everything, this classical window, this balusters, everything should depict classical Roman style and edit. And this should be 12 inches, I guess. Apply and okay, that would look much better. Yeah, fine. Okay, and now let's just go to first floor again and HR. Okay, sorry, HR and do the needful over here. So again, window. And herein, what we can do is that we'll just place a door and solid flush. And just one here and here there is a wall. Oh, I forgot the wall. WA and internal wall. Where is it? Yes, internal 5.4 and just do this to terrace level and just do the needful. Flick, location line, core face exterior from here to here. Yeah, that's fine. Okay, and door and one, and I'm just putting a normal door. That's okay. But anyway, we're not going to see it. Just flip it. Okay, and here we have a sliding folding door which has the access to balcony, and balcony also we forgot. So what I'm going to do is that door and where is that sliding folding? Yes, and I'm just going to host it here. But the width of this is 8 feet, I guess. So edit type and duplicate again. Just rename it. I'm not wasting time on that. Just 8 feet height and 8 feet of width. Apply and OK. Yes, OK. And just shift it a bit. OK. OK. And here we have an access to balcony. And before that, just give it a height of 51 mm. Okay, so we need to provide a balcony over here. So that's just quickly floor architecture. And let me just select washroom floor plate, nahi, which was one. First floor plywood, yes. And draw that with same constraints. Okay, yes, okay. And just finish. Don't attach. And here in this compound wall, parapet wall, CS, that is create similar. Draw from this point and this. Okay, and let's just see it in 3D. Okay, perfect. And we have perfectly created that. Only thing is that I guess that this 8 feet is too much. 7 feet 6 inches will do the job. Apply and okay. And go to first floor and just shift it a bit, move and move it from this point to somewhere over here. Still move it. Okay, perfect. And now 3D. Yes. Okay. So everything is done. I suppose that this door should be changed to the interior door. Where is it? Yes. And that will have a conflict with wall. Yeah, but that's fine. And the space. Okay. And this doors also space, space, and flip the direction and space, space. Okay, fine. CCR enter. Yes. Okay. And now what we are going to do is that we are just going to select 1, 2, and 3, and 4. And all of that, copy to clipboard and paste align to selected levels. And we are going to host that to, to which level? First floor. Yeah, okay. Wow. See how fast, how beautiful. Okay. And I suppose that we are supposed to join this, uh, join and join this to this. Yes. And we have one uniform surface. And oh my God. Okay, let's not waste time on this now. And let's see the image. What does the image says about that particular part? Yes, and okay, here there is the ventilation and the sliding door, and okay, that's fine. So this particular door will be here at the bottom also. So just copy to clipboard and align to selected levels and to lens level. Fine. Okay, beautiful. And yes, 1, 2, and 3. And let's say that the base offset to be minus 12 inch. Okay, not base offset. Yeah, actually, 18 inches and unconnected height up to 4 feet 6 inches. Yeah, fine. Okay. Yes. So we are completely done. Now, only thing left is the biggest task, and that is the sloping roof we have to design for this particular structure. Okay, and that is the real challenge because that roof is very difficult to be made. Okay, just select all this and let's change it to main wall 2, not main wall 2, main wall 3, I guess. That would look much better. Yeah, fine, perfect. Some design considerations. Okay, and now we need to create that particular roof. So let's quickly do that. And for that purpose, I essentially need to go to terrace level. And here we can't see anything, but let's go to first floor and put a reference line and select this particular line and edit work plane and just take it to terrace level. So we have something to reference in order to place that AutoCAD plan. And next part is that import CAD and navigate to that particular location wherever you have saved this particular terrace plan of that AutoCAD plan, terrace level of that project, and preserve all inch and manual center with the settings. Just bring this AutoCAD plan over here and yeah, fine. And with that, just move this point to this point. Okay. And now just have a cross check by going to underlay and turning this to first floor. And yeah, so see, it's perfectly overlaps. Fine. So this is the, and I'll say again none. Okay. And let me just take you to this particular house and you see that this is the roof which you are supposed to design, which has this unequal pitch on both the end. and it is quite, we'll have to do it differently, and it is a bit difficult process in order to create this particular roof. Okay, so fine. See, I'll just show you this particular plan, and yeah, see. So this is unequal pitch on both the sides, and this is the ridge, which is leaning, having slope on both the sides. Okay, so let's just do that. So in order to create the roof, I'll just go to architecture and roof by footprints. Okay, and we are going to lay that roof here. So front part roof plate, I'm just going to edit it and duplicate it and call this sloping roof. Okay, and edit type, I'm just going to get rid of this particular members, since anyway we are just going to use this particular roof as a reference and nothing else. Okay, and with that I'll just apply, and fine, I will just draft the boundary, or I'll just pick lines since we have AutoCAD lines to reference to. And with that lines drawn, I'll just say that define slope uncheck, and just finish. Okay. And with that, you see that that particular roof has been laid, but it's a flat roof. So how to convert it into a sloping roof? So I'll just go to terrace level and wireframe, and I'll just draw a reference line. I'll just pick lines 1 and 2. Yeah, fine. And with that roof selected, what I'll do is that I will just say that modify sub elements. Okay. And with that, I'll just add a split line from here to here and here to here. Okay. Now, what I'm going to do is that I'll just take you to this particular section. This is the schematic section of that particular roof, which we are going to place, wherein we want this point, the highest point, exactly in center of this particular passage, as per the drawing and as per the images, reference images. Okay. So this side, it is going to have lower pitch, and here it's going to have this particular size. We are going to use these dimensions as a reference in order to create that particular sloping pitch, unequal pitch. Okay. Wherein this is from this level, this is the terrace level, and this is the first floor, and this is the ground floor. Okay. And yes, ground floor, first floor, and terrace level. And from here, this roof is having a pitch of 6 feet. The 6 feet high over here. And here it is exactly 10 feet. Okay. So we are just going to do that. So what I'll do is that I'll just select these points and say that I want this at 6 feet, and this to 6 feet as well, and this to 6 feet as well. Okay, so it has created this much portion, but we need one more point over here. So Li, and I will just draw one more reference line. And then what I will do is that again I will create this and modify sub elements and add points, and I'll add a point here. So that will make that particular roof equal. So modify, and this is 6 feet, fine, and this is 6 inch, 6 inch, and six. Oh yeah, so see, we need to make it 6 inch. Fine. So with that, at least this particular roof has been designed. I'll just get rid of this reference line which we drew in order to pursue that thing. Okay. I don't want unnecessary lines. Okay. And with that 3D. And yeah, fine. So at least this pitch has been created. Fine. Okay. Now, what the next part is that we have to join this particular wall and we have to attach this roof. Another part is that we have to have this gradient, this particular part of roof in this ways. Okay. But in order to do that, first step, there is a hierarchy of steps which we need to follow. That is, if we don't attach this wall and first create this steep slope, then you won't be able to attach this wall later and you will end up into errors. So first is that I'll just select this particular one wall and this wall. Okay, both these walls, and I'll say that attach top base, and I'll just attach to this roof. Okay, this has been attached. We need to attach this as well. Okay, and here this attach top base and attach. Yes, fine. Okay, so we have created that particular roof, and now we need to define the slope of this side. Okay, so I will just go to again terrace level, And I'll just take this particular section over here and draw a reference plane over here. Fine. And just go to set and pick a plane and pick this particular plane and go to that particular section. So, fine. Sorry. Just hide all of this. I don't need it. Okay. What I need is just the roof. Okay. And CC, not say CC, let's say that HL is fine. Yeah. Okay. Now we want this particular roof to exactly flush at this point. Okay. But for that, I need this slope. What does this slope says? And I just press tab and I'll just take it here. Okay. And if I continue with this slope, then at this point we won't have height. Okay. So in order to have a desirable slope, what I'll do is that I'll just take this reference plane and snap it or delete RP, RP, and yes, this is the point where I want that slope to. So herein, I will create this particular slope. Okay. With that, I will just draw LI, or let's say I'll draw a reference line which will connect to this point. And with that, I would say that this is going to be minus 10 foot. And here I will just say that modify sub elements. And herein, I will just take this above. Okay, fine. So let's just see it in 3D. Okay, fine. So what is this point? 1 feet and 10 inch and some variables. So I'll just copy that and CC R enter and paste it here in order to have equal steep slope. Paste it here as well. So again, this slope has CC. So I need to, yes. Okay, so this will have at least this surface will have a uniform slope. Okay, don't worry about this pitch. That's okay. We can manipulate it differently. Okay, and with this, now I'm just going to select this and I'm going to say that minus 9 foot and this too minus 9 foot as well. Not 9 foot, minus 9 foot 6 inches. And here too, just click undo, undo, yes, and minus 9 foot 6 inches and minus 9 foot 6 inches. Okay, and let's just see the intersection. And what you notice is that you almost have achieved that particular slope, except for that this point should be here in order to achieve that slope as per the reference line. Okay, so we will bring that point 6 inches still down. So modify elements and go to 3D and wireframe. Yes, and minus 10 inch, minus 10 foot and minus 10 foot. And with that, if I just go to section 1, then you see that we have created that slope perfectly the way it is designed here. See, this is how you create a custom slope in Revit, okay? And with unequal pitch, okay? And then I will just get rid of this line, reference line, you don't need it, and neither this reference plane, okay? And with that, we have created this, and just go to 3D and CC and just create this and attach top base. But now this is going to create a problem. So just Control Z, undo, and this is a difficult roof. So we just need to have patience. And with this roof attached, I'll just modify sub elements and this is not, yeah. So just to manipulate that particular one point, we are losing the connection. Okay, and wireframe, just select this, CC, and say that minus 10 foot. Yeah, so see, As soon as I make this 10 foot, and it will lose its connection. So doesn't matter. What we can do is that we can work it out the way around. Wherein I will say that I want this slope. I'm happy with this slope. I guess that this is proper. We'll just select this particular reference plane and delete it and RP and draw a new reference plane from wherein we'll say that we want this particular slope from this point to this point. Okay. And just press space and extend it. Okay. And it is just a little bit of variation and LI up till this point. And I'll draw one more line. Okay. And what is the height of this line? I'll just delete this and I will say that I want this line all the way till this point. And yes, some ugly fraction, but that's okay. In order to achieve that, modify sub-elements and just keep that slope. Yeah. Okay. So with that, we have achieved that slope. We have tricked Revit. So that's fine. Okay. And just delete this lines. And what you need to do is that enter that same pitch onto this point as well is in order to have that uniform slope. So yes, and yes. Okay. Okay. And yes, fine. So with this, we have created our enter that roof perfectly. Okay. Don't worry about this junction. You can just, what you can do is that just go to modify and cut geometry and cut this much portion. And then just select this particular roof and edit footprints. And while in that drafting mode, you can just go to that particular designated floor plan and just get rid of that extra, this particular niche that have been created. Yeah, see, from here you can just get rid of this. But right now I'm not just going to waste time on that. Okay, fine. So this is perfectly created. Only thing is that we need to join this external walls, 1 and 2, attach top base. Yes. And also this wall, attach top base. And likewise, this walls. I cannot select this wall. And why is that like that? Rabbit sometimes behaves weird. Press tab and yeah, and attach. Okay, and one more, the last wall. Yes, and say that attach top base and finish. Okay, and yes, if I just hide this particular thing, then you see that we have this particular sloping roof. Okay, and here you can just add ventilation or grill or something. We don't need to attach this wall because anyways, those are going to be the internal walls. Okay, and this space can be used for storage or truss members or laying of truss members or whatever. Fine. So this is how we have defined this particular roof and the pitch of that roof perfectly according to the image and according to the drawing. Okay. Now I'll just select this particular thing and hide in view by category since we don't need it. And yes. So what is the next step? The next step is that what we need to create is that the truss. The first is that truss member. And for that, I need to take you to this particular section, terrace level and here. Okay. And fine. So here there will be a truss. Okay. At this point, there will be a truss which will be supporting this particular roof. And we are actually going to use this particular roof to create the members of a typical roof. To explain you that better, I will just take you to this particular drawings and what are the typical members, what are the members of a roof. So that follows that there is a ridge member, okay, which follows this, this, the one, two, and from here, this and LI line and oh, L enter, sorry, and this and one more, yes. So these are the ridge. Okay, these are the ridge members of a sloping roof. Then fine, what is next? There are joists, which we won't have in our case. Then we'll have rafters, wherein we'll have the common rafters or valley rafters. Okay, and then there's ridge board, and then these are the purlins. These are the purlins which will be supporting this common rafters. These are the rafters, and this purlins will support that. And on the top of that, we will have uh, battens, which will be having that roof plate. So this is the exact cross section of that particular roof which we are going to design today in Revit. Wherein this is the fascia board, this is the beam, and this is the truss system which we are going to design, and these are the purlins. See, these are the purlins which are supporting that rafter. These are the rafters. Okay, these are the rafters, and this is the ridge board which I just showed you. Okay, and this purlins will have that rafters, and that rafters will have this battens. Okay, and on the top of that you'll have your roof. Okay, so this is the hip rafter which will have, since we have a sloping roof, since we have a hip and valley roof. Okay, so hip rafter, and this will be the common rafters. Okay, and this is the wall plate. Yeah, wall plates, I forgot to. Yeah, this will be the wall plates. The wall plates we have also defined the wall plates. Okay, this I have downloaded some images wherein you see that this is how the construction happens, and these are the batons. This green colors are the batons, okay, which are lying on the rafters, and on the top of that, we'll have design such roof. Okay, so this is the exact image. So you see that this is the column, and this particular thing is the wall plate. This is called the ridge. Okay, this ridge is having the rafters, and those rafters are having the batons, and on the top of that the roof has been laid. Okay, so we are going to design all this very technically and with all the details in Revit today. Fine. So first step is that we have to lay the truss member. Okay, and in order to lay that particular truss member, I have already filed, and I'll go to structure. Fine, and structure and truss, and I've already designed that particular truss pertaining to this slope. Okay, so the placement plane should be a reference plane, fine, and reference level, terrace level, fine, and just no, but before that, in order to place that, we need to define two reference plane, one to here. Okay, and sorry, not truss, but RP and reference plane, one over here and another over here. Okay, and with that, I'll just say that truss, and with that PTS truss and reference plane, okay, and to reference level to terrace level, I'll just click this point and click this point. Okay, so that particular truss will be created. Fine, and I'll just select this to reference plane so that, and just delete it. Unnecessary lines I don't want. Okay, fine. And now we need to adjust this height. So what I'll do is that I'll just select this entire truss and say HH and LI and draw this line over here. Okay, and just select this line and copy this dimension. You see that it's ugly fraction. So just copy it and delete that line as well. Okay, and HR, and with that, select this truss and go to its truss height and select this and paste it. Fine. So with this, you see that it absolutely follows the roof. And the reason for this is nothing but edit family. And I have manually designed this particular truss system in a such a way that it will perfectly follow this slope. Okay. Wherein this is the top chord, this is the what do we say, web, and this is the bottom chord, and likewise this also the vertical members and this height at different level. Okay, so fine. Now what we just need to do is that we need to again select this particular thing, and let's say HI. Okay, until we can just see that. And with this, what I will do is that I'll select all of this, SA, and all of that are selected, and I'll just unpin. Okay, unpin, since we want to change the members, the size members of the size. And if I just go to 3D, and you see that it has been laid like this. Okay, instead of this wooden, right now I'm just following this, taking this conventional wooden truss. If you want to design a steel truss or aluminum truss or metal truss, then or concrete truss, whatever, then what you need to do is that what I did is that going to structure and going to this beam and load family, you have this structural framing, you have this various different folders from where you can access this steel members, wherein you will have this I section and various. Okay, so C section, C channel, I channel, and concrete also. But I have selected this wood, and under that this timber beams. Okay, so just following the conventional method. Fine. Okay, so let's just go to section 2 again. And what I'm going to do is that with that unpin, I'm just going to move all of them and move to center. So that will, because it is right now referencing in the center of that, you see that dotted line, and press tab, move, and move it to center, and move center. Okay, and with that, this should connect at this point. Yeah, okay, and fine. Now we need to change this members. So I will just select all of this and SA and deselect this. And for this, I have already defined various sizes of this. So I'm just going to select this 2 cross 3. Okay, fine. And all this SA, all four of this should be 4 cross 6 timber. Okay, 4 cross 6. Okay, so yes, the sizes remain the same. Fine, but now we need to join this properly. So how will we do that? So in order to join this properly, we have this command modify, and under that we have this not join. Okay, but yes, so with that, if I just select this particular thing, then you see that you have this notch. Where is it? This will be having it. Oh, notching distance. So we selected the wrong element, and select notch and notch this to this. Okay, and select this and notching distance. I'll say that 0. Notching applied, but no cut was made. Notching distance or extension parameters. Just hold on. Wait, for that, I essentially needed to snap it to the center of this. And then, yeah, see, so it's done now. The notching has been done. Okay, fine. And if you want, I'll just show you some tips and tricks. You just draw this reference plane. Okay, and select this and extend it. And what you can do is that cut and select this particular thing, cut, select this member, and yeah, fine. So with that, you can have, but if you delete that reference line, again, that member will pop up. So let that reference line remain there, okay? Doesn't matter. And again, this should be at this point. Okay, fine. And we have a diagonal miter joint here, but here we don't have it. So notch and this to this, and notching distance to 0. Uh-oh. Yes, fine. Okay. And with this selected, just notch 1 to 2. Uh-oh. Notch this with this, and say that the notching distance should be, where is it? No. Yeah, here is it, 0. Okay. And HL, then you won't see that particular element. Fine. And just like that, extend this to the center point and create a notch. So no, notch this element 1 to 2, and with that selected, 0. Okay, and likewise all of this, just extend it to center, and that's already joined, I guess. Okay, fine, but herein we need to create. So just extend this all the way till center and this to center. Okay. And just create notch connections, notch this and notch this. Okay. And with that, select this and say that 0 and 0. Okay. And we have a flush connection. Fine. And let's just see it in 3D. And yes, okay. Also this member and RP, this reference plane, press tab a couple of times. Okay. And just cut. Select this element and this reference plane. Yeah, that's fine. Okay. But don't delete that reference plane. Okay, fine. HL. And again, a notch connection of this to this and select this notching distance to 0. Fine. And we have a flush connection. Let's see it in 3D. And that looks much better. Okay. Only thing is that section 2 and we need to move this element halfway. Okay. And yeah, that will remove the notching. Fine. So remove notching. Yeah, that's fine. We'll do that once again for this too. Then that's okay. No big deal. So just notch it this with this member. And yeah, fine. The notching distance is 0. And notch this also. Okay. And that too is also 0. That's fine. 3D. And now it's look pretty much perfect. You can select your category or your preferred option, whether you want it to be MS, steel, aluminum, concrete, or whatever. But this is the concept, how you build this particular thing. And you see that this needs to go a little bit down. Okay, fine. Okay, with this selected, I will just say that press tab, select one member and SA and hold control key or select tab first and then hold control key and select this and press tab, select this, uh, press tab, select this, hold control key and select that, okay, and SA. Okay, with this selected, I'll just say that copy and copy it, or let's say that array. Array will be much better. And array from this point to, let's say that 5 feet, okay, and number 2, move to number 2, and I want 5 of them. Okay, perfect. Fine. And that's just the concept, how you lay your truss members. Okay. Also, now you need to go to individual, what do we say, element. Press tab and just see right now this is array, so it's the group. Just ungroup it. And you can go to the individual section of individual members and draw the reference line and have this connection just like I showed. Okay. But that was just wanted to show you the concept. Fine. So now let's proceed on further. And what is next? Next is that, and we have to design the different members of this particular sloping roof. Okay. So let me just press HR and yeah, fine. So in order to design the different members of this particular sloping roof, which I just explained to you a couple of minutes back, wherein we'll have the wall plate, the ridge member, the rafters, common rafters, valley rafters, and on the top of that battens. What I just realized that the method with which we created this particular roof is not compatible for laying that particular grid. Since we are going to use this conceptual massing insight and this conceptual mass in order to develop a surface onto which we can lay this particular tiles, which I just explained. We are going to lay this particular battens and ridge members and rafters, everything in the tile format. Okay. So this particular thing is not compatible for that. But I just wanted to explain you that what are the different ways of creating the roof. but we will use slightly different method for creating this particular same roof. And we will do that just quickly. And I'll just copy this. Okay. And yes, and I will delete this particular roof which we have made. Okay, fine. The truss members does exist, but now we have to define that particular roof again, but slightly with a different method. So what I'm going to do is that I'm just going to go to terrace level again and fine. And what I'm going to do is that I'm just going to create Li and snap to these lines for reference 1 and 2. And we are going to create that roof by same way, that is roof by footprints. And I'm just going to draft, but we will create this particular roof not in continuous, but in two parts. Okay. The process will be same, but just two different parts in order to perceive that achieve that particular thing. Okay, and fine, and wherein I'll just finish, and this will be laid on terrace floor. Okay, so this is on terrace floor right now. Okay, I'll just go to terrace level again, and I'll just say that modify elements and add split line, and I'll add one line from here to here and one more line from here to here. Okay, and if you remember, then this particular point, what was the height of that? So now we are going to go to 3D and use this particular thing as a reference to snap those points. And this is Control C and modify elements, and this Control V, and this point Control V, and this also, I guess, the same. Okay, fine. Next is that modify sub elements and this points. So 110. Okay, and I'll just go to terrace level, and again I will just create HH and no, okay, fine. So that is not needed. Yes, so I will just create this particular roof and modify sub-elements, and this to 110 and this to 110, and that variable ugly fraction. Okay, and that same here as well. But this entire pitch will remain as it is. Okay. Okay, now we need to create the another part of that particular roof, which I'm just going to create differently in order to do the job. So I'm just going to say roof again by footprints. And this time I'm just going to draw a rectangle and yes, and remove slope, define slope and check and finish and modify sub elements. And this too will be negative 9 foot 6 inches, if you remember, and negative 9 foot 6 inches. Okay, and this will be modify sub elements and 10 and whatever. Okay, and with I just I go to 3D and we have our roof, the same roof, but slightly with a different manner. Because see, you see that here there are a lot of points. In order to pursue this as the one homogeneous form, one uniform form, uh, one surface. It has created the different parts and it's difficult to, I'll just show you. See, real quick, I'll show you. I'll go to just massing and site and in place mass and yes, and mass one. I'll just click this to HL and I'll just draw these lines. And with 3D snapping on, I will just draw 1, 2, 3, 4, 5, and 6 and 7. Okay. And now with this selected, if I just try to create a form, solid form, then you see that it will create that particular form. Uh-oh. Oh my God. Oh, that's done. And that is something which I discover new because when I earlier tried it with this same command, then it created different parts of that. This is something weird. Anyway, the same thing we are going to try here as well. So not to worry. Okay, just fine. And this cancel. And okay. Otherwise, what it used to do is that it created pattern for all this different 1, 2, 3, and 4 elements when hosted on this particular walls, when hosted by walls. Yeah. So when hosted, since this is right now individual, so that's why it created that. Otherwise, when it is hosted by walls, that will create different pattern for this surface, this surface, this surface, and this surface. So we cannot have this uniformity. And I'll just select this particular wall and attach top base and this to this and this to this. Oh, sorry. And attach top base. Fine. And with that, I will just select this wall and this internal wall. One, two, three, and all of this. Now this is going to take a bit of time. Yes, one and this. Okay, and all of this and attach top base. And yes. Okay, so we have pursued the same thing. Okay, and let me just wireframe and get rid of this two lines which we use, and I don't need it anymore. Okay, and HL. Fine. And we have the same roof. So HH, and yeah, fine, everything is perfect. HR, and let's go to section 2, and you see that its slope is following and it's completely perfect. Okay, we don't have any issues. Sloping roof, and yeah, courtyard wall paint, that's fine. Okay, what is the next step? Next step is to create other members of this particular roof. Okay, fine, but for that surface, but for that, I will just turn it to HL. Sorry, not HL. R enter, that is realistic. And let me just temporarily hide this particular roof. And we use two types of truss here. There's one is this 4 cross 6 and another is this 2 cross 3. Okay, so let me just go to the family section of this and let me be very specific since we are going to lay a lot of members and I don't want to get confused. So rename, and this is going to call truss. Rename this as truss, copy, and rename this as well truss. Okay, and this two timber 2 cross 3 rename and call it truss, copy and expand it and rename this as well to truss. Okay, fine, so we don't get confused. Anyways, now we are going to create the next part is that we have to create the wall plates as I explained you in that image. This wall plate, this wall plates which will be resting on wall and which will be taking that roof. So we have to design that. We have to lay that. Okay. So what I will do is I will just say that architecture, structure, and beams. And for this wall plates, I'm just going to use that same 4 cross 6 truss. Okay. But what important is its Y justification, which I'm sorry, Y justification, which I'm going to say that left and the top offset. Z justification to top and top offset value to be 4 cross 6. So 6 will be its depth. Fine. So I just want it to appear exactly on that particular surface, and very important architecture and set plane, pick a plane and pick this particular plane, and then architecture, structure, and beam. And with that beam selected and all this, I will just pick lines and yes. Whoa, perfect. It had been laid perfect. Only thing that we need to displace is a bit. So this wall is 15 inches. So let me just have a guessing games minus 5 inch and Y. Okay, undo and yes, select this and Y to be 5 inches. Yeah, so see, negative 5 inches. Perfect. Okay. And then what I will do is that it's not exactly in the center, but you can just manipulate it. You can just, you need to drag it all the way till the center. Fine. So this will be the wall plate. And if you want, you can insert it a bit in the wall with, let's say that 3 inch. Okay. Fine. So that would make sense. But right now, firstly, let's lay all the fine and highlighting all the overlap. Yes, that's fine. Okay. Let me just save it before I lose something. And again, say that beams, and with that same properties and y offset value to -5 inches. I'll again pick lines, and this time I'm going to set this plane. Actually, I was supposed to select the plane first and then the beam. But yeah, that's fine. Okay. Pick lines and select this. Oh, perfect. See how perfect. Next, this particular part. Okay. Here also we have walls which are going to, so again, architecture and set, pick a plane, pick this plane, structure, beam, and this time the offset value will only be 2.5 because this is a 9-inch wall. Okay. And negative. Just guessing games. Oh my God, perfect. C and pick this. Okay, and just displace it a bit. For this, I guess that positive will work. No. -4 inches. Yes. And this has been laid to a wrong plane. I guess that should have, let's just delete it. And let me just select this beam again, and with 3D snapping on and pick lines. And since this is the sloping roof, this wall is getting cut. This There is a roof on this, so we have to use a different method to lay it. Yeah, fine. See, perfect. Okay, and this concrete element, yeah, because we forgot to. If you forget one step, then you see that it creates so much a problem. And pick lines, and yes, oh, perfect. How perfect it is. Concrete. Yeah, see, again, this is a sloping roof, so I need to be very particular. Wherein I'm going to say that set plane, set work plane, and this to be terrace level. Okay, and with that structure and beam and placement plane to be terrace level, I'm just going to pick lines and select this. And yeah, see, perfect. Okay, I was not getting this earlier, but somehow I thought that I got it. Okay. One over here and one over here. Fine. And these two walls are the smaller walls. So actually there is no floor plate needed here, but fine. Let's just reduce the size, but that will again have different properties. So let's go to beam and this time select 2 x 3 truss and Z offset value to be 0 for now, and displacement is fine, and pick lines. Where did it create? Placement plane is terrace level. Yeah. Okay. This and this. Okay. And give it a Z offset value of 3 inch. So that will Z offset 3 inch. Yeah. Perfect. See, and I think that we should ignore this particular corner. That's fine. Okay. And this, I guess that this should snap to this point. Okay. Fine. So with this, we have laid the floor plates. I just select all of this SA, and you see that since it is a similar type, so it is selecting all of that. I just hold Shift key and deselect this, but it's not deselecting. So I guess that 1, 2, 3, and I'll have to select an individual. So that was the purpose. I was saying that we should have duplicated it. before placing it, or we should have created that different type, but that's fine. Okay. And yes, this should go Z offset value to 3 inch. And yeah, that would make it much more realistic. Okay. And I guess that HR, yes, so this wall also needs to attach top base and so somehow lost its connection and join elements. Yeah, fine. And this to attach top base and this. Okay. And then just HH and HH this as well. And just take this particular member all the way, all the way till this point until it snaps. Fine. Fine. I'm just teaching you the drafting skills. There are a lot of other technical things needs to be taken care of while doing modeling such things, but I'm just ignoring that part. And I guess that this should snap here. Okay, fine. So this thing is done. Now what is next? After laying this particular wall plates, now what is next? Next is that we have to define purlins. Okay, and for that we are going to make use of this roof. So I'm just going to press HR and select both of this and right click and uh, override graphics in view by elements and just change its opacity to something like 70. Okay, apply and okay. Fine. So we can have a see-through. Now what we can do is we are going to use an alternative method to design that particular thing. And it's going to be very interesting. No, but before that, yes, one more thing which is left is that we need to place the ridge board and valley rafter. Okay. So which is important. Okay. So let's just do that. And let me just press undo until I can. Oh no, but yeah, we can do it here as well. Yeah, fine. That's okay. HI and yes. And I'll go to beams and I suppose that that size has already been defined by me. That is 4 cross 18. We will lower it later once it's placed. But right now I just say the 4 cross 18 and placement plane terrace level and 3D snapping on and just pick lines and pick this and pick this. So see how easily it has been created. Only thing is that you need to, oh, but beam and not left. It accepted the same properties. I want it from center and y justification to 0 and z offset value to 0 as well. Okay. And with that, pick lines. Okay. And okay. And now I'm just going to select both of this and say that z offset value should be, if this is 18 inches, then it should be 18 inches. And that will perfectly lay it in place. Okay. So just like that, this is the ridge board. Okay. We need to create this valley rafters. Okay. So I'll just go to beam and once again we will use this 4 cross 12. Okay. And for 4 cross 12 with center and the shop and top offset to let's say 12 inch, that is 1 foot. I will just again pick lines and with 3D snapping on, I'll just place it. Oh, okay, perfect. Fine. So no issues. We just need to drag it a bit, drag it a little bit until it snaps perfectly. Yes. And here now again we'll have a flush connection earlier, just like we had it. Okay. And yeah, so see how perfect it is. See? Okay. Only thing is that we need to extend this a little bit. And with this, now what you can do is that also take this all the way to the center And fine. In order to have a flush connection, what it's need to be done is that go to modify and notch. And with this, create the notch joint, select this part and say that notching distance to 0. And we have a clean joint. Okay. Just like that, notch this element with this and this element with this and select this and notching distance 0. And it's perfect modeling skills. Fine. And likewise, notch this to this and this to this as well. I know, but they are not joined, so no point. So select this ridge, this valley rafter, not ridge. This is the ridge board and this is the valley rafter, and fine. So perfect. Okay. And I will just HR. Fine. So next is that we need to create ridge members. Okay. And let me be very specific, 4 cross 12. Let me just rename and call it ridge board. Ridge board, copy and rename ridge board. Okay. And likewise, we have used this 4 cross 12. So those are rename valley rafters. All this is used in scheduling, quantification, and everything, costing. So that's why I need to be I always prefer to be very specific if you ever want to find this, because now you'll be using the same elements a lot of times. Okay. Yeah. So fine. Now let's move forward. And what I will do is that I will just say that HI, both of this also and this also, and HI. Okay. And what I'm going to do, I'm just going to go to massing and site and in place mass and call it sloping roof ridge. No, yes, ridge. No, not ridge. Purlins. Oh, sorry. From when I'm just calling you the purlins. These are going to be purlins. Okay. So HL and this members are called purlins. Yeah, fine. Which is supporting the rafter. The common rafter and the valley rafter are the purlins. This this particular, and on the top of that we have the common rafters, and that on the top of that we have the batons. Okay, fine. So from when I was calling this particular member wrong. Okay, so now just create and set plane and set work plane and select this bottom plane. Okay, since we are going to draft from the bottom of the roof, and create and line, and with 3D snapping on, just create it from 1 to 2, and let me just be very careful if I don't snap to any wrong lines. And using that particular roof, we are creating this actual roof members. Okay. And yes, with this, what I'm going to do is that create this, select this, and say that create form and say that solid form. And see, it's one homogeneous piece. Okay. Which is not the case if that roof is done by that previous method. And what should be the height of this? We want to make it start from 6 inches only. No, 6 inch is the height of the roof. So let's say that not important, minus 2 inches, I will say. No, but that will not create. I would again, yeah, I would say that 6 inches, exactly like that particular roof. And then I would say that divide surface. Oh, perfect. Now, what we have to do? No, but this particular method is needed when we want to create the roof tiles. Okay, right now we don't need to create the roof tiles. I'm extremely sorry, guys. Uh, First is that, sorry, finish mask, sorry, undo and cancel mask, and yes, discard this particular thing. And this we will use, this particular function we will use last. First is that we need to create the ridge members with the help of this structure tab, and under that we have this beam system. Fine. So we'll click that particular beam system, and then I will just create this particular lines, and I cannot create boundary lines. Why is it not allowing? Okay. So set architecture and set and pick a plane. This should be the plane and structure and beam system. And then, yes, so then it will allow to. Okay, one and HL2. And let me be very careful. Sorry, I was supposed to start from here. One and this bottom. And this. Okay. And this. Okay. And then the beam direction should be this. So I'll say that boundary line, just go to top of this and draft from here to here. Okay. And with that, not boundary line, beam direction. Beam direction, I will draft line from here in this exactly perpendicular. Okay. And with that, with the distance of 6 feet, 6 feet or 5 feet. Yeah, 5 feet. Let's keep it 5 feet. That's okay. And justification to center or end, we can just first lay it and then we'll decide. And the beam type should be 4 cross 6 others. See, others. I will rename it to be purlin, but right now let's just say and finish. Okay. So the purlins has been made connecting that particular wall plates. Okay. And I'll just say that SA and 4 cross 6 others. I'll just change this particular others name to rename and call it purlins. Let's be very specific and copy and rename it. Paste again purlins. Okay. Yeah. And just select all of that, and SA justification can be changed depending upon its location, but that's fine. Okay. And I would say that this should have a Z top offset value of, since it is 4 cross 6. So let's say that 4 inch, not 4 inch, 6 is the depth there. And perfect. Okay. So now that if I just press HR, but before pressing HR, I would just like to change this material to something so we can differentiate between the materials. Okay. And I'll just click wood, and we have a lot of wooden panels. Appearance, yes, that's some dark, okay, some dark shade, okay. You can apply any material, but yes, okay. So this is it, and I'll just press HR. Fine. So you see that now this particular supports wall plates are supporting this ridge, not ridge, ridge board is this purlins, okay. This I'll call purlins, which we have created using this beam system. Okay, and again, I'm just going to select this beam system and this roof and just press HI. Okay, and I'm just going to make use of this existing beam system a couple of times, but press tab, this beam system and this roof and this roof. Okay, and HI. Okay, now with that beam system selected, what next we have to do is that we have to lay the rafters. Okay. rafters. Valley rafter we have already placed. We need to lay the common rafters. So I'm just going to use this very powerful function, copy to clipboard, place, align to same place. Okay, so that same place and that particular system has been laid by same place. But I'm just going to change this to, or I'm just going to edit this particular system. Edit boundary. Yes, and with that edit boundary, what I'm going to do is that HL and top, since we have created a duplicate copy of that particular beam system, so this is the different beam system, okay? So I will just say that the beam direction should be from here to here. This should be the beam direction, and the distance should be, let's say that 2 feet for now. Let's first place and see. And justification is not important. And this, we will say that rafters, ready rafters, and we haven't defined the truss for that. So we will use that same 4 cross 12. Okay. And you see that that particular thing has flipped its direction. Okay. And I'll just go to edit type. No, but 4 cross. Yeah, that's fine. Okay. And just finish. Okay, so those rafters has been placed, but the distance needs to be bigger, let's say 4 feet. Yeah, so that would make more sense. Okay, select this one, SA, okay, valley rafter, and so that would have selected essentially that also. So this is the problem that occurs when you don't define a different type. So select this SA and just deselect this two. Okay, and now we need to place it at particular location, its specific location. So right now it has been placed with respect to this. So I will just say that the Z offset value to be 12 inch, or no, how much? 6 inch is the roof. Yeah, 6 is the top offset value to be 12 plus 6, that is 18 inches. Because no, 12 is its own thickness. 12 inch try karte hain. No, see, so 12 inch is its the thickness, it's its own thickness plus the thickness of the roof, so 18 inches, I guess. Okay, perfect. Fine. And just go to edit type and duplicate this and call it what? Common rafters. Common rafters. Okay. So any changes we make to it, so that wouldn't ref reflect here. Okay. And what I will do is that again, I'll just change this material to something else in order to have a different look. So I will just click wood, and we have a lot of wood materials defined by me already, and wooden panels, rafters, this we already used. So let's use this. Okay. Wooden panels, rafters. Yes, just use this. Dark and R enter. Okay. See? So see the hierarchy. Wall plates, wall plates supporting wall plates supporting the purlins supporting the battens, sorry, rafters, common rafters, and that is hosted by this particular ridge. See, perfect connection. Now, on the top of this, we again need to lay uh, battens. Okay, battens. So what I need to do is that again, I need to select both of this and HI. Sorry, select this as well, and select that roof as well. HI. No. select this roof and then that structural beam, sorry, the beam system. Press tab. Yes. So this is the beam system, but we are now going to place the batons which are in this direction. So just press tab again until you, yes. So see, it is highlighting HL and this beam system is highlighted. So hold control key and select that as well. And with all that three selected, just press HI. Fine. Okay. And now again, same process, copy to clipboard, paste to align to same place, and that would lay it. But this time we are going to say that 2 cross 3 other, okay, which are going to be batons, okay, and its distance will be just 18 inches. Both are the small elements, small members, okay, and I'm just going to, where can we change its material from? Timber 2 cross 3. But yes, that's okay. We'll change the material. But first is that 2 cross 3 others, I will just rename and call it batons and copy. And I'll just change this to rename as well and batons. Okay. And that will again SA. And with that selected, it doesn't select anything else. See, this doesn't select the members which are part of this 2 cross 3 are the members which are part of this trust system also. But since we have SA, yeah, we have renamed this. So different type. Okay. And this Z justification would again be 16 inches, I guess. Z offset value 18 inches, not 16, sorry. Yes, perfect. Absolutely perfect. Okay, you can lay it on the top also, but as far as this image is concerned, what we are seeing, yeah, so you can lay it on the top also. Okay, so what we'll do is that I will just give it an offset value of 3 inch more, so 19 inches. And no, acha, 19, 18 and 19 is 21 inches, sorry. Okay, and that are perfectly hosted on the top of that. Fine. And with that selected, I just press SA and the structural material of timber 2 cross 3, but I guess that batons and this other truss members. So where else is it hosting? This other truss members, yeah, fine. So why is it saying multiple SA? Yeah, okay, it's a structural material varies. And we are just going to apply different material and just this material, or let's me just select wood. And let's see that what materials do we have. And pine. Where is pine? Yes, this is it. Pine. Okay, pine is already loaded. So pine and pine southern and okay and yes and HR and R enter. Sorry. Okay. See how beautiful. Okay. Perfect. Fine. And now see, we have almost reached this stage. Okay. So now finally, the last step is that we have to provide the roof tiles. Okay, don't worry about these junctions. As I explained before, whenever you draft this roof, you just need to go to edit extrusion and edit this much part and get rid of this part. But right now, I don't want to waste time on that. I want to concentrate on modeling part. Okay, so next is that the last step that we have to add the sloping roof tiles and the ridge, okay, ridge tiles. So first is that sloping roof tiles. So for that, now I need to select this particular two roofs and go to HI and repeat that same process which I earlier did by mistake. That is by going to massing insight and say that in place mass and call it sloping roof tiles. Okay. And H. And with that, I'll just create lines, or let me say that pick lines. And with this time, with offset of and the work plane selected to terrace level and draw on face and pick lines. And I would just say that with the offset of 3 inch for these two lines, one and two, because it will have um, the ridge member on the top of which there will be tiles again. So that should not collide with this tiles. So one and two, and then just turn off the offset and draw pick lines, regular lines, or we can even just draw lines from this end to here and from and likewise on this point and complete it. Yes, okay. And with that, now we just need to TR and join this to this, and we have a close shape. Fine, but what we need to do is that we need to go to front elevation and move this loop. Just uncheck constraint and move this loop 6 inch down. Okay, since if you remember that the last batons that we laid was on 21 inch from this particular point. Okay, so with this selected, I would just say that create form and solid form. Unable to create form. Oh, might be somewhere the drafting error. Yes, so see, one and two. This should be a close shape. It should be essentially a close shape. And this with solid form. And yeah, perfect. Absolutely perfect. And this should be 21 inches. Okay. And on the top of that, I would just say that divide surface. And perfect. Absolutely perfect. Okay. And now we are going to lay the tiles on this grid. And this was the purpose we did all that conceptual massing. And because I wanted this to create this pattern onto which we can lay the roof. Okay. And since the tile which we are going to lay is, I know that it's 15 inch by 1 foot. Okay. And with that, I would just, with this selected, I will just drop down and I have already loaded that particular tile, sloping roof tile main segment. See, and just create. And you see that your actual roof tiles are created at particular that level. Fine. And you see that it's how perfect. Okay, you can now shuffle between and just leaving 3 inch space from this point in order to lay that particular, and you can just shuffle between this justification wherein if you want the styles and it is starting from perfect. Okay, and herein let's change the just justification for V grid to beginning. Yes, and you have a full tile over here also, and at this end also. Okay, and this is having a full tile at this end, and here there is a residue, so that's fine. Okay, and just R enter. Okay, perfect. And with that, I'll just select this entire mm, this particular thing, and let's right now let's it be visible. Fine. So just press HR and see that how perfect and how beautiful. Okay. Only thing that this particular glitch, and actually there's not a glitch, but whenever you, I hope that you understood the concept and the process that whenever you create that conceptual mass environment or that conceptual mass form, in order to flush this particular thing, you have to manipulate and lay that line or give the offset that line. closer to this particular ridge member in order to flush this. Okay. But apart from that, as far as the modeling part of the structural members and everything is concerned and the roof member is concerned, it is absolutely perfect. Okay. Now I'll just say that component and with this soaking rough tiles line based ridge. Okay. So that pertains to the tiles of ridge. Okay. And don't worry about the placement right now. Just try to understand the concept and just get conceptually clear. Once you are conceptually clear, then you can design it the way you want. Okay. I'm just making you clear your concept. And this is creating a problem. So let's just HI this particular one element and architecture and component. There are several ways when something doesn't work in one way, then you have to try a couple of options and lay it. Yeah, fine. So see, it's laid. And HR and this particular, this would be the same HI and component and from this point to this. Okay. And HR again. And the last from this point to this point. And following this same process, we have to complete this entire roof, this particular process which I just showed you of laying the different elements of roof at different work plane at different heights and different levels. Fine. But you as you see that it's taking a lot of time. So you just stay tuned and just follow. I will just complete all of that and get back to you in a while. Fine. Yes. So finally, after a lot of hard work, I've been able to complete this entire project, which with all its complete details and exactly we have achieved something which is looks similar to this particular project. Okay. And you see that this particular thing has been an attempt has been made to achieve this particular thing, of which the major highlights of this particular entire project was this particular sloping roof, wherein I have not added fascia to this element, and that is purposely because I wanted to show you the details, the details that are within this particular roof. And if I just select this SA and HH, then you'll be able to see that we have achieved all that particular details which I showed you in the beginning of this particular project, that is the hierarchy of the elements of this particular roof, wherein I was saying that we have this particular, where is that image? Yeah. So the wall plates which are taking this particular rafters, this rafter, this ridge board, the purlins, and finally the battens on the top, and most essential important part, the truss members. Okay. And all of that has been achieved here. And this project is complete with all its complete details in the modeling part. Okay. And if you want to just see the details of this, then if I just say that section box, yes, let me just turn on the section box so we can just go into the house. And I'll just go to front and let me just, okay, fine. And you see that this particular thing has been properly executed with all its details, wherein I have added furniture, dining table, and you see that this parametric window, the sliding folding doors as per the project. Okay. And this is completely done, complete. Okay. So we just get rid of this section box. Fine. But this was pertaining to the modeling of the 3D interface of Revit with its all perfect details, joint condition, structure part, the wrapping layers of floor, walls, the finishing floor layers, and join condition and everything. But as I've been always saying, that Revit is not only about the modeling of the 3D interface, but it's very prominently and efficiently also does models the 2D interface. For to demonstrate that, I'm just going to open up this existing project of mine, which is live project February batch, and the video you will find on YouTube on ptscad expert app YouTube, and under that there is a playlist Revit BIM, and under that all my videos I have provided. Okay, so I'll just so the viewers which have seen already this particular project, that so this particular part doesn't pertains to them. But the new viewers, I would just like to bring to your notice that the modeling, along with the modeling of 3D interface, the Revit very prominently and efficiently does model the 2D interface. That is the essential building information and the assets which we feed to a particular structure for its execution on site, which again has the 2D interface has a bifurcation. That is, one is the composition of drawings, preparation of different types of drawings, and another is the costing and scheduling and quantification, which is the most important part. Okay, so you see that this particular project, these are the floor plans, and you see that this is the presentation plan, and we have this the working plan of this particular same set, the same floor plan. We have this working drawing of that. Okay, along with that, we can create such exploded views. Okay, apart from that, you have this beautiful elevations, presentation elevations. Okay. Not only that, you can also create sections and you can convert them into presentation or working sections, whatever you want. And as I said, that drafting like AutoCAD is pretty much difficult in details, pretty much difficult in Revit. So what you can do is that you can just bring the AutoCAD drawings of the details and create a sheet over here as well. Okay, this is the area gross plan, and often designers are interested in the space calculation. That is, how much is the circulation to open, to private, public, semi-private services, and all that. Okay, and finally, apart from this, what we have is the schedule and quantification, the most important part of this particular Revit, wherein we can calculate various schedules, and you see that this is the entire door schedule with all its details, and you can add as many details as you want. You can also add, see, the cost factor I have already added, and these are the different types of doors that are used in this particular project, and that to floor wise with its total counts. Okay, that on third on first floor there are total 13 doors. Okay, of which D2 type is 2 and D13 is 2. Okay, in two instances, and this way we can completely detail out this particular schedule also, and find your see. So floor wise also you can segregate, and apart from that you can have the materials. You can have the quantification and costing of this particular material areas, that on this particular plinth ground floor so many materials are used which is having so much of square feet area. Okay, and just like that, we can create room schedules and a lot of details. It has window schedule, wall schedules, wall material takeoff. That is, what are the materials that are pertaining to essentially the wall. Okay, and its area and its volume and everything. Okay, and finally is this particular sheet composition, which is the best part. Of course, we as the designers will never issue the sheet in this format, but this is just to show you that drawings of different disciplines can be clubbed together and composed in such a way in Revit. Okay, it also has this revisions. Okay, fine. Revisions also can be added, and schedules and exploded view and all this part of this particular project. Okay, so coming to our project, we can do apply the same all that details to this project as well, and which we are going to start in the next phase, that is phase two. Okay, that is the 2D part of this particular Rabbit. Okay, so if you found this video interesting, then kindly enroll for this course and let's learn together and let's grow together. Fine. So from Monday's class, we will continue with the next part of this, that is annotate, and we'll start here from dimensions. Fine. So just watch the video and get up to this point and let me know if you have any doubts or queries. Bye.